Hi grade 12s, welcome to my channel. Let us discuss this paper from the Northwest written in this year's prelim examinations. This is just a way to try and assist you guys to prepare for the final exams and of course any other time that one may be facing the exams after watching this video. Okay guys, we were supposed to have a class yesterday and today. Unfortunately, due to time constraints, I couldn't make it to our class. So I hope this makes up for the time lost. We're going to carry on tomorrow and finish up on our trigonometry. Right. Doesn't look like we have any instructions here. So we're just going to imagine our general instructions. I feel like this is too much. It's too thick. Question 1. So, question 1, guys, it's a warm-up. Nothing really out of the ordinary here. So we've got x minus 3 into 15 into 3x plus 15 equal to 0. Now folks, this one is easy. X is 3, or x is going to be minus 5. Right. So again folks, we never take this for granted. We need to check our solutions for correctness. Remember, the mishandling of a digit or a sign can really result in a disaster. And it happens always when one is too comfortable, right? So if we put a 3, that first bracket becomes 0. So 0 multiplied by anything is 0. So the left-hand side balances the right-hand side. If we put a minus 5, we see that the second bracket becomes 0. And essentially anything multiplied by 0 is 0. So the left-hand side balances the right-hand side. We can then move on safely, knowing that we have scored maximum marks there. Otherwise, truly speaking guys, questions like 1.1 are grade 10 questions. No grade 12 should be spending time at this stage practicing such questions, but rather doing them meticulously and ensuring that they are done to perfection. Alright, so 7x squared minus 4x minus 5 is equal to 0. So this is the standard quadratic, and obviously this instruction already highlights that our roots are irrational. So we will need our friend, the quadratic formula, or what may even do it by completing the square, which is essentially the same thing. Okay, so this is over 2a. So this implies that x is equal to minus into minus 4 plus or minus the square root of the square of minus 4 into 7 into minus 5. All of this divided by 2 into 7. Okay. Honestly speaking guys, at this stage I don't find any interest in simplifying because it is of no consequence whatsoever. Okay, we've got the square root of minus 4 all squared minus 4 into 7 into minus 5 all divided by 2 into 7. Okay, so our first solution here is 1, 1, 8, or x is going to be, obviously I know that I'm expecting a negative root. Why do I know that? Well, if we think about our graph on the Cartesian plane, just to get you guys to know some things. So if this is our graph on our Cartesian plane, this is our origin there, we will see that this graph has a negative y-intercept, whereas the middle term is negative and the first term is positive. So what does this mean? It means this business right here. it means this business right there is what gives us our axis of symmetry. And so it means our axis of symmetry is on the positive x-axis with a negative y-intercept. And again, knowing that the a value is a positive number, so this means our graph is definitely going to have a negative root and a positive root. So our parabola is going to be of this manner with the turning point over there. So we already have a positive root, so we should have another negative root. So again, guys, one can also be able to comment on nature of roots by just looking at the equation. And of course, doing forward calculations, so to speak. Okay. So folks, what we get here is minus 0.61. So obviously, that's what we expected, and we got it. But remember, we don't celebrate just yet. We check our solutions, because we move on here knowing very well what we have gotten. Okay. So if we do that, what do we see? So now we see that the right hand side is a whole number, so we will need to round off whatever we get to the nearest whole number. And when we do, it is effectively 0. So 0 is equal to 0. The left hand side is equal to the right hand side, essentially. So rounding off here is a form of rationalizing the denominator there, technically, or at least rationalizing those roots. Anyway, let's look at the next root, minus 0.61. Okay, guys, there's no room for errors at this stage because this is now the main event, right? Again, the same root here, effectively rounded off to the nearest integer, we get 0. So we know we are good, and so we get our marks, okay? Get it right, guys. It's very easy. Now let me highlight something. What is the importance of indicating the formula? Say, for example, a student executes this incorrectly, ending up with, say, for example, an incorrect substitution. This means the student loses everything. But let's say we write an incorrect formula and we substitute according to the incorrect formula. We would still get a mark for substitutions, but lose the 2 marks for the solutions. So this means one may still stand a chance of not walking away with a 0 here. So take these guys seriously. They are very important issues. This is the so-called positive marking, which I really am against personally, but it is what is being enforced currently in the curriculum. All right, we've got x squared into x plus 4 is to be less than 0. If we inspect here, we will also see that this is just for 2 marks, so it's not complicated. So what are we supposed to do? We'll see that from inspection, x squared is always positive or is equal to 0. So we can write, since x squared is greater than or equal to 0, for all x element of real numbers, this implies that for that product to ever be negative, the bracket must be the one that's negative. So therefore, our x must be less than minus 4. That's the solution. Nice and easy, not complex there. Perhaps stating that fact and ending up with that deduction makes a bit of sense, right? But remember, students, one is still allowed to use our tools if we know how to use them correctly. So if we've got x squared here and we've got x plus 4, we put them on our table of signs and work out where the solutions lie. Remember, we are doing a product over there. So we would list our critical values in ascending order. So the first one should be 0. The second one would be, first one is going to be the negative, minus 4 and 0. Okay, we list them in ascending order. Right, so let's deal with this one. So what happens here? When we substitute a negative number, we get a positive. It's a perfect square. We still get a positive. We get a positive. We get 0, then positive. And for the second one, we get 0 when x is minus 4, and this becomes positive everywhere else beyond that, and it becomes negative below that because this is a linear expression. So we say positive times negative, we get a negative. Positive times 0, we get 0. Positive times positive, we get positive. 0 times any number is 0. Then positive times positive is positive. So what are we saying? We want our product to be negative, meaning less than 0. And we see that 0 is not included. So if that's the case, this means we need to not include the 0, but we go in that direction. Okay, so this makes up for the conclusion that x must be less than minus 4. Okay guys, this is important to know. It is important to know, because these are one of the ways of solving anything and not lose marks unduly so. But again, we can think about our business as a function, or at least functions on the Cartesian plane. Now, when we look there, we will say that essentially this as functions on the Cartesian plane, the x squared is a parabola, and this courses through the origin like that. So this is our function of x squared. So, and if we say that's 4, perhaps minus 4, that would be the straight line equation. Again, I don't care to showcase the intersection per se, but what is important is this critical value here, minus 4. The y-intercept of 4 is not really that much of a big deal. This is when we model these functions, perhaps as this one f and the other one as g. So the usual question would be to say, for which x values is f of x times g of x less than 0? This can be a question on graph interpretation when we get to functions. And what does that f of x mean? It means y values of the function f. And this one also means y values of the function g. Right. So when we multiply these for the same x value, what is the product of the corresponding y values of the two functions? And we need it to be less than 0. So when is that? So if we look and assess our business, remember, always look for a vertical line of some sort and move it around to gauge what's happening. We study from left to right. So if we perhaps park over there, what do we see? We will see that essentially the y values for our g function are negative, whereas the y values for that same x value are positive. And that product is less than 0. So this is good. And we know that, okay, this continues up until we get to the critical value. What is there? The y value is 0 for our function g, but it is still positive for our parabola. So 0 multiplied by any number is going to be 0, but we see that 0 is not included. So we need to exclude our critical value. So all we can do here is we know that we cannot have our minus 4 there included. Okay, we keep moving. Remember, we are checking and scanning through. If we move past, for example, for that x value, both the y value of g and the y value of f is positive, so that product cannot be less than 0. When we get to that critical value for the parabola, we will see that we get a product of 0, so 0 is not included. If we park it to the other side of that critical value, we'll see that, again, the y value of the parabola and the y value of the straight line are both positive. So that gives us a product that is greater than 0. So this means we cannot consider those parts of our solution. Right, so we can get rid of our straight line now, because this is in the exam, guys. One needs to use a ruler to make sure that they're being accurate. Okay, so essentially what is the feasible region here is to the left of our critical value -4. So normally when we read those solutions, we would perhaps look at -4, open circle, and move in that direction. Of course, that is how we get our solutions. So in essence, we can write here that x must be less than -4 as a conclusion. So it helps, guys, to consider these constructively. And of course, one can still look at the algebraic expression and use algebraic interpretation to technically get to an answer still, right? But remember, we need to be very elaborate as to what we are doing. All right, guys, so that's easy 2 marks otherwise, no problems. So we do 1.1.4. So we are given the root of 5 minus 2 to the exponent 2x. This is to be equal to 2 to the exponent x minus 3. Right, we need to solve. So we know what to do here. So we're going to do this again. Just copy this and do this gymnastic in there. We need to perform our gymnastic. Goodness, what is happening now? 2 to the exponent x like that, minus 3. And we know that, guys, with radicals, depending on the index of the radical, once it's not written anything, it means it's a 2 automatically. It's a square root, hence we square. We perform inverse operations. Be prepared, students, to essentially, meet with a cube root. And so we have to cube both sides. But the one that we probably don't need to worry about is a fourth root, although it can be given, but I doubt, because it's not part of the syllabus. We don't do quartic functions, so essentially it may not be something a student may encounter, but perhaps some rational index may be a consideration, of course. So we need to be very careful. But of course, it will be set up such that we are able to proceed with our inverse operations and get to an answer. So let's see, guys, what happens here. We get 5 minus 2 to the exponent 2x equals, here this becomes 2 to the exponent 2x minus, this is going to be 3 times 2 to the exponent x times 2 is going to be minus 6 times 2 to the exponent x plus 9. Obviously, most students would probably resort to the so-called K method. All right, at this juncture, it's okay, but I wish for you guys to be able to handle these head on without essentially flinching, because it helps to know algebra deeply than just to always use these shorthand techniques all the time. When the going gets a bit messy, it becomes very difficult. So seeing these head on helps a lot. Right, so we move everything because we can imagine some quadratic expression. Now remember, this is going to be positive, so there's going to be 2 of them. So we just add as we would, and then we've got minus 6 times 2 to the exponent x. Transpose 5, we get a plus 4 equal to 0. We can divide by 2. So we get 2 to the exponent 2x minus 3 times 2 to the exponent x plus 2 equal to 0. And we know that factorizing here is possible. This is familiar territory. So this is 2 to the exponent x, 2 to the exponent x. We get minus 2 and minus 1. So this implies that 2 to the exponent x is 1, or 2 to the exponent x is 2. Now we play with our algebraic techniques and using exponential rules. We know that if we want to have a base of 2, this is going to be 2 to the 0, or this is 2 to the x equals 2 to the 1. We just show that exponent. So we make a conclusion that x could be a 0 or x should be 1. But remember guys, we don't celebrate just yet. We check if our solutions are correct. And we check where? In the original. And here the checking is mandatory. Without doing it, a mark can be lost. So if we look there, when we put 0 where x is, what do we get? We get 0. Therefore, 2 to the 0 is 1. 4 minus 1 is 5 minus 1 is 4. Square root of 4 is 2. So this is a positive square root of whatever is inside. So this is a plus 2. We get here. We put a 0 there, we get 1. 1 minus 3 is minus 2. Can you see we get 2 is equal to minus 2? That's not true. So the solution gets struck. Then we check the other one. We put a 1 in there, we get 2 squared, which is 4. 5 minus 4 is 1. Positive square root of 1 is plus 1. Put a 1 in there, we get essentially a minus 1. Again, this solution does not balance the equation, so it gets struck. Alright, so what do we say then? Because if it is not those, so what? Well, we can make a conclusion and say this was the only possible way we could have some kind of an intersection if we think of those two terms as functions. So we can say there's no solution here for all x element of real numbers. Perhaps this is just overcommitting, but remember, if it is not those, so what should it be? Then we need to come up with a conclusion, right? Right. I mean, this is not usual, so sometimes this may cast a bit of doubt in one and be like, did I make a mistake? You end up going back and forth looking for something that is probably not going to change, okay? So what do we do in this instance? Remember, we do a further check. It's like when you have a hunch as a doctor, one day when you become them doctors. You see, sometimes you think of some diagnosis that is very likely given the clinical scenario presented before you, but you still run a test to confirm it. We do the same here. So like, okay, if we think about these two terms on either side of the equal sign as functions, so what vibes should we get to perhaps get the idea of whether we are making the right conclusion here or not? So we look at this. We will see that this is an exponential equation, essentially an exponential function. Now we see the coefficient of the power is a positive 1, okay, meaning a is greater than 0. So what does that mean? It means this function will appear above the horizontal asymptote, which is going to be the constant term, okay? If we look at the base of the power, it is a value greater than 1. So this means this is an increasing function that appears above the horizontal asymptote. Okay, let's put it on the Cartesian plane and see what we are going to observe. Perhaps let's make this a bit longer. So be comfortable, guys, working graphs, okay? Be very comfortable. Now, here's what we've got. Now we see that, okay, if we say this is where our horizontal asymptote is for this right-hand side function, we want to establish whether there will ever be an intersection, because the solutions are merely intersections of the two graphs. Right, so what we will see that is that this graph is doing stuff like this. Okay, so that's the graph. It's gonna do stuff like that. We can call it f if we wish. F of x. And almost when we do things on the Cartesian plane, we perhaps want to name them. for convenience and ease of reference. Of course, guys, when we work out the y-intercept, it becomes -2, isn't it? Yes. And what about the x-intercept? This is when y is 0. Transpose the 3. The variable is on the exponent. We apply logs. So from log rules, this is going to be the log of 3 to the base 2, right? So one needs to be quick. So this gives us an x value of 1,6 to just one decimal place, just for convenience as well. So we know this is what this graph should look like. Can you see, guys, we've gotten an accurate graph without really doing too much, just understanding how things work. At this stage, honestly, there's no excuse, students. Now let's face what is on the right-hand side of our equal sign. What we see here is a radical function, so to speak. But if we zoom into what is under the square root, we will see that what is under the square root is an exponential equation of this order. Y is equal to -2 to the exponent 2x plus 5. Okay. Now, we see that essentially with the coefficient of our highest power here, which is that 2 to the exponent 2x, it's negative. Remember that negative is not for the base, but it's the coefficient of the entire power of 2 to the exponent 2x. Now, when this is the case, we know that this is a graph that appears below the horizontal asymptote, which would be given by 5. Essentially, that is an exponential function. Okay, but we look at our base of the power. This is essentially a value greater than 1. Now, what does this mean? This is a decreasing function that appears below the horizontal asymptote of 5. But now, folks, we took a square root of this expression. So in essence, what have we done? When we take the square root, what we're doing an inverse operation. Remember, with an exponential expression, when we take a square root, we're actually doing an inverse. So this essentially translates to some log function, right? Because an inverse of an exponential equation is going to be a logarithmic function. But why am I saying some? Because this one, it has some, there is more restriction to this than just the usual restriction, which is at the vertical asymptote. There will be more restrictions. Why? Because we know that this function, remember, we took a positive square root here. So essentially, for this to even exist, we're going to have to consider that what is inside can never be negative. And if it is never negative, it means what we get as a result will never be negative, right? Because we follow what is written. What is written is that this is the positive square root, not just any other square root. So again, this is where it gets very hectic sometimes. So this means this graph is not expected to appear below the x-axis, but it's a log function, right? So let's test. Now we wonder, how are we going to proceed? Remember, in grade 8, we are taught to use a table to get the shape, because we're not so sure. Sometimes if you didn't know this is going to be a log function, you don't know what it looks like. So to get a feel of what this should look like, we check values, right? So let's say 0, 1, 2, -1, -2. Just want to get the feel. Of course, as a student of maths, you don't need a complete picture before you can get what's going on. Since we have an idea, we just want to prove if this is true. Right, we will say that if we substitute essentially 0 in there, we get the square root of 4, which gives us 2. So this one becomes 2. Okay, so this function is sitting at 2, for example. We can say that's the point. There is 2. Okay. And we want to consider when this is 1. So let's say 1 is over here. Okay, maybe that's not quite right. Say this is 1 over here. So what happens? When we put 1, we saw that we got 1. So this means this graph is over here. But now, we get overwhelmed. We can see that we can check we can check 1,6. So I say square root of 5 minus 2 to the exponent 2 into 1,6, right? So this already gives us a math error. So we know that with the log function, we get a vertical asymptote. So if we get a math error by the time we are looking at x of minus, not minus, but x of 1,6, this is suggesting that we essentially have hit our vertical asymptote where the graph is limited. Okay. So what about checking more? So we can check, okay, if 1,6 doesn't work, what about 1,1? So 5 minus 2 to the exponent of 2 into 1,1. So that gives us a 0,6. So when it is 1,1, very close here, what do we get? We get 0,6 essentially. So this is what this looks like, okay? So you see, it's really starting to approach an asymptote. When it starts doing this, we know that we are approaching an asymptote. But the question is, can this be 0? Is it possible? Well, we can try and say, well, when will something like this be 0? So this is 5 minus 2 to the 2x equal to 0. We still perform our gymnastics. Get 5 minus 2 to the 2x equals 0. We transpose this, we get 2 to the 2x is equal to 5. And of course, we can see that x is going to be the log of 5 to the base 2, all divided by 2. Right, to solve for x. Let's find out. So we've got log of 5 to the base 2 gives us an answer. We divide that by 2. It gives us 1,16. So it's a very small little thing. So we know that, okay, at 1,16, which is roughly 0,2, but we're not going to get to 0,2 because why? This already gives us a math error. So we can say this is probably not very far from there. And of course, we can just approximate our vertical asymptote at perhaps say 1,2, you know, which we can just approximate it there. But remember, guys, it's not really accurate, but it's just getting an idea across. So we know that, okay, this function can be 0 here, but it never dips below the x-axis because this is a positive square root. So we need to be very particular. So this function is doing stuff like so. Right. So we can see that this is a decreasing function that is limited at that 1,16. Okay. So now if we look at these two graphs, we know that if they were ever to intersect, it would be below the x-axis. But since that function g, if we think about it as such, since that function never goes under the x-axis, so these functions are never likely to meet. And so this means our conclusion here is perfect. Okay. So guys, it helps again to explore what these things are and what the implications are thereof. Okay. So to think of a function and using, you know, what we have learned in the previous grades on how to really explore a function in a way, we now know that, okay, there's no x value where these two graphs are going to be equal unless we create some conditions for them. Right. So this means, guys, we get a mark for our gymnastic, right? Whenever we factorize, we get a mark. rejecting these solutions. Those are marked. So 1, 2, 3, 4, 5. Where's the sixth mark? Maybe here the gymnastic of using exponential rules, that is on its own something algebraic and mark worthy, or perhaps working all the way until there, but it's only 6 marks, and that's what we get. Right, so we've got 1.2 simultaneous equations. So we've got 2y minus x equals 3. Therefore, if we isolate x, we get 2y minus 3. Can make this equation 1. And the second equation is y squared minus 2x squared minus x minus 1 is equal to 0. So all we know is that this is our equation 2. So we put 1 into 2. What do we see? It's going to be y squared minus 2. Where we see x, we put 2y minus 3. This is squared minus into 2y minus 3, and minus 1 is 0. So we get y squared minus 2. We fold this out, we get 4y squared minus 2 by 3, that's 6 by 2, that's 12y plus 9, okay? Minus 2y plus 3 minus 1 is equal to 0. So what do we get? Y squared minus 8y squared plus 24 y minus 18 minus 2y plus 2 is 0. We sort it out, we get minus 7y squared plus 22y, essentially minus 16, equal to 0. Now, normally students want the quadratic formula here, but you see, brave ones and the well-cooked ones, they know how to factorize this thing, right? So this is 7y, y. Now we need to look for factors of 16 if they're going to help us. So 4 and 4. 7 by 4 is 28. 28 minus 4 gives us 24, not 22. So that's not going to work. If we look at 8 and 2, I would have to say 7 by 2, that's 14, plus 8 is 22. Yeah. So this means we put minus 2 there, and we put plus 8 there. So we can make a conclusion that y should be, so minus 8 divided by minus 7 is 8 over 7. Or y should be 2. Okay. If that's the case, we can substitute into our equation 1. X is 2 into 8 over 7 minus 3. Or x is going to be 2 into 2 minus 3. So what do we have there? So let's just check it on the calculator and not waste time. We get minus 5 over 7. Here this is just 1. Okay. Again, guys, we don't just celebrate the answer. We check if we are doing the right thing. So we check those values back into one of the originals, provided it is copied correctly. Okay, we've got 2 into y. This is 8 over 7. Ooh. Minus into minus 5 over 7. We get 3, so this means the left hand side is equal to the right hand side, so we can accept those solutions. And if we plug 1 and 2, so this is going to be 2 basically times 2, which is 4, then minus 1, that's 3. again, those solutions actually are true. And of course, we normally get a mark for the method. It's usually 5 marks, but the 6th mark most likely manipulating that first equation. So guys, this is very easy, and you know how useful this topic is when we get to functions and beyond. Okay, points of intersections. Very, very important. Okay, we've got our 6 marks and we smile on. So let's see 1.3. Question says we need to show that the roots of p equals 19 minus 3x squared all over x are real for all real values of p, where p, I've just said it. I don't know why I want to repeat. Okay guys, so we know that p is equal to 19 minus 3x squared all divided by x. We cross multiply. This implies that px is going to be 19 minus 3x squared. See, we've got a quadratic, so we write it in standard form. So we write 3x squared plus px minus 19 is equal to 0. And we know that for us to evaluate the nature of roots here, we need to look at the discriminant. We know that the discriminant is b squared minus 4ac. So what is this? It's going to be p squared minus 4 into 3 into minus 19. This implies that our discriminant delta is going to be p squared plus, say 4 times 3 times 19. We get 228. And that's not a perfect square, is it? No, it's not. So this is what we see. And if we look at this discriminant function critically, we'll see that this is essentially parabolic. And it is a smiling parabola. So if we think about it on the Cartesian plane, this is what we see. So this is the p-axis and the delta axis when we adapt our stuff. So this parabola has a minimum value of 228. So this is the graph like this. All right. Okay. Don't know why it's refusing to do what I want. Do it, do it, do it, do it, wena man. Okay. So our discriminant function would perhaps look like that on the Cartesian plane. So the minimum value is 228. Can you see? This means it is positive for all real values of p. So this could be part of the solution, obviously, but we would just know that this means that our delta is forever positive. It's greater than 0 for all p an element of real numbers. If that's the case, we know that the roots are real for all p an element of real numbers. Okay. Good stuff. So this is not a very difficult question. Easy if one understands what to do. All right. So I suppose writing this quadratic in standard form is important. Substituting into the discriminant and explaining what the discriminant looks like. Coming up with the conclusion gives us the last 4 marks. And this was a very tasty and fairly easy 23 marks. Okay, right. So let's move on to question 2. So question 2 tells us to consider the following geometric series. Now we know what this is, okay, which is very important. 2.1, we know that we've got a geometric series p plus 21 plus 63 plus dash 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 plus 137,781, okay, as our last term. It's a finite series. Alright, so if this is geometric, I mean, we can tell what the common ratio is. From 21 to 63, that looks like 3, right? 21 times 3, yebo. So we know that the common ratio here is going to be 3, since we know what this is. So we know from the one term to the next, it's going to be fairly a ratio that we can get from the two terms. Alright, so the first question says 2.1.1. We need to find the value of p, okay? We know that 21 over p is going to be 63 over 21. Just to be methodical, we know that each is equal to the common ratio r, just so that we work systematically. So we know that 63p is going to be 21 squared is 441, right? Let's just check. Some numbers still remain in my head, some just disappear, but again it takes a special moment to lose these anyway. Right, 441, so we can see that p is going to be 441 divided by 63. This is 7. Again, seeing that the common ratio was 3, by inspection one could just say 21 divided by 3 would give us 7. So there are many ways of killing the cat. If the question is open-ended like that, we don't necessarily need to struggle, but again, to form a bit of structure so that we can show we understand what we are talking about, it sometimes helps. But remember, there's 2 marks for the answer only for those who did it by inspection. It is possible here. In fact, it is allowed. The instruction was not so strict. 2.1.2 says determine the number of terms in this series. Okay. So we know that this is a geometric thing, so we can say t sub n is a times r to the n minus 1. We substitute. This is 137,781 equals a is 7, r is 3 to the n minus 1. Okay, so we divide by 3 there, so we've got 137,781 divided by, divided by 7. We get 19683 is equal to 3 to the n minus 1. Okay, so we shift and fact the left hand side. Shift, fact that thing. It gives us 3 to the exponent 9. This is equal to 3 to the exponent n minus 1. Now, using our laws of exponents, we know that essentially if the bases are the same, it also means the exponents should be the same for those two to be equal. Therefore, n is 10. So we answer the question. We can say, therefore, there are 10 terms in the series. Right. Nice and easy. Always get to the point where a conclusion has been given fully. We don't want to be saying, okay, if n is 10, so what? The question was the number of terms. Okay, folks, so substitutions here and working out the common ratio, so to speak, I would believe is important, and saying how many terms we have. All right, so that is essentially how stuff gets done there. So let's see, what do we have here? 2.1.3 says we need the sum of this series. Okay, this is easy. So we know S sub n is going to be A. Since r is greater than 1, so we're going to write this formula. Okay, so we know that there's 10 terms, so it's going to be S sub 10. It's going to be 7 into 3 to the exponent 10 minus 1, all divided by 3 minus 1. Therefore, our S sub 10 will give us what we have there. So let's see, 7 into 3 to the 10 minus 1 divided by 3 minus 1. So we get here 2, 0, 6, 6, 6, 8. Okay, nice and easy. Okay guys, so this one is straightforward substitutions and answer. Okay, easy stuff. So again guys, when you get a chance to move on quickly, do so please. But when the going gets a bit risky, take a bit of time, but be reasonable. Right. So now we are told here at 2.2 that a school hall is filling up at a rate of 10 learners in the first minute, 14 learners in the second minute, and 18 learners in the third, and so on. So what do we see? We can see that the number is increased by 4 each time or each minute. So this is an arithmetic sequence with the common ratio, the common difference of 4, right? So this is what this is. So we've got an arithmetic sequence or progression, but again, if we're filling up a whole, so these numbers are adding. So we can say it's an arithmetic series. We get 10 plus 14 plus 18, and it keeps going. Right, so first question says, how many learners enter the school hall in the 8th minute? So we want T8. So 2.2.1. We know that T sub n here is A plus n minus 1 times D. So this means T sub 8 is going to be 10 plus 8 minus 1. Common difference, we saw that is 4. Therefore, T sub 8 is, this is 7 by 4, 28 plus 10. This gives us 38. In fact, let's answer the question. What does the question say? How many learners? We can say 38 learners enter the school hall in the 8th minute. Okay, answer the question, students. Answer the question. Okay, right. So we used our maths as a means to an end here. So we get a mark for the correct substitutions and the answer. Obviously, working out the common difference was also an important issue. So again, guys, as you can see, there's nothing complicated here. Right. 2.2.2 says, the school hall is a fifth full after 8 minutes. Okay, now after how many minutes will the school hall be full? So obviously this is now a higher grade question. Okay, it's one of those questions that you just cannot solve. So as a student, you may have to decide, are you skipping this question and coming back to it later, or do you have the right thought behind it? Well, first thing to do is that, okay, let's find out how many learners are actually the full capacity of the whole. So we can say let X be the total number of learners in the full hall, right? Right. Such that we were told now that after the 8th minute, it was a fifth full, such that 1 over 5x, right, is going to be the sum of the first 8 terms. This is what this means. Remember, there will never be a question, or should I say, there will never be a situation where in the exam, the arithmetic sum is not somewhat looked at, okay? So this implies that 1 over 5 x is going to be, now this is arithmetic, so we know that the number is 8. We divide this by 2. The first term was 10, the last term is 38. So we don't want to write silly things. We know that S sub n is n over 2 into a plus l. Just put that as a reason, you see. Be creative so that your maths flows. You don't want to just answer haphazardly. Right, so we know that basically x over 5 is going to be, let's see, what is it there? So this is 4 literally into 48. So this gives us 192. So this means x is going to be that times 5, which is 960 learners. Right? So technically the full capacity of this hall can accommodate 950 learners, right? Is it 950? 192 times. Here we're 960. Yeah, silly things, folks. Silly things. So please don't be absent-minded when doing these. Be very, very, very conscious. So now that we know the number of learners, we can find out how many, essentially, minutes are involved here. Okay, which is the number of terms that we added. Because the minute is the term position here. You can say now then, we know that S sub n is otherwise n over 2 into 2a plus n minus 1 times d. So the examiner is forcing us to use the other formula somewhat. How so creative. So this implies, guys, that we've got 960 equals n over 2 into 2 into 10 plus n minus 1 times 4. Okay, good stuff. So what are we doing? We've got 960 equals n over 2 into, now this is 20 minus 4, that's going to be 16, and then this is 4n. So this is what we have. So when we distribute, we've got 960 equals 4 divided by 2 is 2n squared plus 16 divided by 2 is going to be 8n. Now we see a nice quadratic here, so we've got 2n squared plus 8n minus 960 equals 0. Can divide by 2. We get n squared plus 4n minus, that's 960 divided by 4. Not by 4. 960 divided by 2 is 480. Okay, equal to 0. Obviously, I just shift and fact that 480. So this gives me 2 to the 5 times 3 times 5. Now that's 32 by 5 minus 3 is not going to work, okay? We need to break this up. So this is 2 to the 4 times 2 times 3 times 5. Now 2 to the 4 is 16 by 2, that's 32, and 15 is not going to work. 8 by 3 is 24, 24 and 15. That doesn't give us 4, okay? So we need to break this further. So this is 2 squared times 2 squared times 2 times 3 times 5. Right. So what do we see there? No, yeah. So 2 squared let's say 2 squared. Okay, by the way, I made an error here. If this was a 4, I'm supposed to make it a 3, right? Let's be systematic so that we don't lose, so we don't end up in trouble. So let's have a look. That is still 2 to the 5. Now let's see, this is 8 times 2, that's 16. Yeah, doch, this is not going to work, but I think I'm supposed to end up doing that breakdown anyway. So let's see. Of course, guys, the quadratic formula there is enough for a student who wants to. So let's see. This is 4 times 5, that's 20. Ne? So this is 20. And then this 4 times 2, that's 8, times 3, that's 24. So we know the difference here is going to be good. So we know that we've got n, the bigger number is 24, into n minus the smaller number. So from here, we can say, therefore, our n is basically 20. Why? Because n is an element of natural numbers. So we can't choose a negative integer. If this is the case, we can make the conclusion that therefore the whole is full after 20 minutes. Please always answer the question. Please make an attempt to make a conclusion. Of course, guys, I said those who are comfortable with the quadratic formula. In fact, I think it is safe to use the quadratic formula, but get used to playing because some questions are going to force it down this path. So when there's nothing stopping you guys from exploring things algebraically, please do so. It's always very meaningful. Okay. Right, so this is done. As you can see, this was a very interesting question, a certain higher grade question, right? No standard grade student would know what to do here. Anyway, let's go on, folks. How do we score these marks? For me, this substitution is important. The total number of learners is also key. This substitution is important, and essentially answering the question. So how many marks? 6. So we have how many? 1, 2, 3, 4. I would suppose this equation was strategic. That's the 5th. And of course, guys, sometimes the gymnastic here can be rewarded. I mean, as long as we get our 6 marks, we are happy. So this was for a very nice and tasty 16 marks. Perhaps the 2.2.2 could have caused a bit of havoc to students. Right, let's do question 4. So question 4, why am I jumping 3? Sorry, question 3. Now question 3, we are told that this is a quadratic sequence. Again, this is very nice to know. So we've got 10, 21, 38, and it goes on. But once we know the signature, we can go ahead and do stuff. 21 minus 10 is 11. 38 minus 21 is going to be 17. And we know that the difference between these two is going to be the common second difference. 17 minus 11 is 6. Okay, so we don't need a second invitation for what we just did. So let's get to business, guys. Again, we can speed up here. Write down the equation of the eyeball. Where am I? Determine the general term. Okay, guys, this is class work. So we know that 2a is equal to 6. Therefore, a is 3. This implies that 3 into a, which is 3, plus b should be 11. Therefore, b is going to be 11 minus 9 is 2. And this also implies that a, 3 plus b, which is 2, plus c should give us the first term. Therefore, c is going to be 5. Therefore, t sub n is 3n squared plus 2n plus 5. Now, guys, we need to check whether the sequence given is truly represented by what we found. So let's check. The first term is 3 into 1 squared plus 2 into 1 plus 5. It is indeed 10. Let's check perhaps term number 3, a term that is not so close, just to make sure there's no coincidences. They have occurred before. We get 38, so we can accept our answer. And of course, any one of those values gets a mark. Nice and easy, guys. See, no need to drop these marks. 4.2. We need the 10th term. So we know that t sub n is 3n squared plus 2n plus 5. T sub 10 is 3 into 10 squared plus 2 into 10 plus 5. Therefore, our 10th term is going to be gives us 325. Now, with this kind of a calculation, guys, the most important step is the substitutions, okay? If they are incorrect, the whole thing founders, all right? So we don't want that. So we are to, can you imagine, guys? See, here's a common mistake. Can you see I'm already writing 4? And that's a disaster, okay? That's a disaster because it means even with those correct, what should I say? With those correct executions, a student may end up getting 0. But I think they wouldn't be so brutal. You probably lose a mark each time. So, again, marks can be lost because of just incorrect labeling. Remember, the general instructions emphasize that we are to label according to the manner in which things are labeled here. Now the last question says, determine which 2 consecutive terms of the quadratic sequence differ with 95. So 95 is basically the term of the first differences. So basically we know that if we look at those first differences, we can clearly see that term 2 is the difference between 3 and 2. So that position will coincide with the lowest term position. So we can just do that without struggling. Say, okay, Tn is a plus n minus 1 times d. So we already know that the nth term here is 95. The first term was 11 in the arithmetic, so we're looking for n. Common difference was 6. 95 equals 11 minus 6 is essentially 5. Plus 6n, so we know that 6n is going to be 90. Therefore, n is, let's see, 90 divided by 6, it's 15. Great stuff. Now we can say, therefore, 95 is the difference between term 15 and term 16. Nice and easy. So that's what we needed. So obviously 3 marks, folks. Substitutions here, getting the answer, and probably working out n. This could easily be 2 marks, but 3 marks is fine. It's not a problem. Again, guys, this is an easy and very tasty 9 marks scored. Okay, now we need to get to functions. All right, so let's tackle that quickly. So question 4, I've been yearning for this question, it seems. Right, so what can we do here? Question 4, we are given the logarithmic function. So we assess if the coefficient of the log is positive, then it means our log function is essentially going to appear to the right of our vertical asymptote. We need to remember that. And of course, if we look at the base, it is a proper fraction, so it means our function is a decreasing function. We need to remember those things. They are very important. So let's start moving. 4.1. We need to write down the equation of the asymptote. It's always going to be the y-axis unless we shift it about. Right, horizontally usually. So essentially we know that the y-axis is the line x is equal to 0. You didn't know that? You are dead. 4.2, we need to determine the equation of the inverse. Again, we can do this by inspection. We know that our inverse is such that y is equal to, now this converts to an exponential function, right? Yes, the base remains the base. Some students may perhaps want to showcase this like that. Y is equal to 2 to the minus x, basically. Okay, there's nothing wrong with that. So we get 2 marks for the answer, folks. Again, if you're still wondering how it happened, please watch most of the other videos that have been produced already. There I try to take you through the process, but remember we can't spoon feed you guys forever, otherwise you will never grow. Now we need to, if g of x is f inverse shifted horizontally 3 units to the right and down by 2 units, we need to find the x-intercept of g, okay? So let's see, g of x is going to be our inverse function. So this is going to be a half of, now once we shift this to the right by 3 units, this is what happens. And that happens too. So we are going to say for x-intercept, it is such that 0 is essentially half of x minus 3 minus 2. So what do? There we transpose the 2. We get here, we can express this as a base of 2. So this is 2 to the minus 1 x minus 3, okay? This implies that this is 2 to the 1 is equal to 2 to the minus x plus 3. Distribute that negative. Same basis, we know that 1 is going to be minus x plus 3. Therefore, our x here is going to be 2. But remember, we were asked an x-intercept. So the x-intercept is going to be 2 and 0. Nice and easy, okay? So this is a very smart way of not really asking directly, but rather transforming the function, which is quite interesting, to avoid asking homework, okay? Yeah, that's good. So obviously, guys, writing the g in that notation is all good. Substituting a 0 there is nice and dandy, and presenting the answer in the required manner. So easy 3 marks here. Okay, so we've got 4.3. We are to write down the equation of the asymptote of g. Remember, this is an exponential function, so the asymptote is given by the constant term. It has a horizontal asymptote, so this is defined by y is equal to minus 2. Easy 1 mark. Right. Now, 4.5. we need to sketch the graph of G and clearly show all the intercepts at the axes and the asymptote. Of course, standard stuff, guys, we need to work out a y-intercept here. Okay, without one, probably are going to be in trouble. But we can do it on the side and put it all together because the question is on the graph, literally. But anyway, let's just do the standard stuff. We can say for y-intercept, this is such that we're looking at g of 0, which is equal to a half of 0 minus 3 minus 2. Therefore, g of 0 is, now this is essentially 1 over a half to the exponent 3. That gives us 8. Ne? Essentially, 8 minus 2 is 6. Good. Very important. So we can say, therefore, the y-intercept is 0 and 6. Okay. If that's the case, we can draw our graph now. Remember, this is an exponential function. Remember, this one does not necessarily have to be according to scale per se, but I'm going to try to make it look at least sightly, you see. Now, if we say this is minus 2, our horizontal asymptote, right, what did we find the x-intercept to be? Is 2. So this graph is doing stuff like this. Right. This is our g function. Maybe let's write it over there. Right, where did it cut? At 2. Right, and where did it cut the y-axis? At 6. So everything is perfect. Get a mark for the shape, x-intercept, working out the y-intercept, and showing the asymptote. Easy 4 marks, guys, and a very easy 11 marks to score. But remember, guys, most important, we need to understand and keep in mind our transformations, be it a reflection or a translation. Okay, nice. So let's get to question 5. Usually there's trouble in this question, so we are ready for whatever comes, okay? But it usually does cause havoc. This one always needs some depth to the understanding. Okay, so we're given that sketched below are graphs of f, which is minus x squared plus bx plus c. But now by looking at the coefficient of our highest power x squared, if it is negative, this is a grumpy face parabola, and we can see that. And of course, this being a fraction, a proper fraction, the gradients are largely gentle, not as steep, okay? That's what we can see so far. And of course, g of x, which is the generic hyperbola or hyperbolic function. Right, the axis of symmetry of f, x is equal to 1, is also the vertical asymptote of g. So this means here we've got minus 1. So this already tells us that at the turning point we've got minus 1 and some y value that we need to find out. Okay. So if this is the vertical asymptote also of g, it means p is 1. We change the sign. Okay. Nice and easy. So these pieces of information are coming in bits and pieces. Now the line H is an axis of symmetry. Okay. Very important to have that given to us, because there can be a line that passes through the center of our hyperbola, but not necessarily being the axis of symmetry. So hearing that makes us very happy indeed. A is the y-intercept of f, so if it is the y-intercept, there's 0 there and some y value of both f and g, okay? B with coordinates 2 and 0 is an x-intercept of f as well as h, okay? That's cool. So first question says we need to show that our equation of f is like this, okay? 2 marks. Nah, man, that's mean. Anyway, 5.1. Let's see, guys. So what can we do here? Now we need to think as to what we can do. I mean, 2 marks, it makes it look easy, but is it so? Is it easy? Let's use symmetry, for example, and say the distance from the axis of symmetry to that point should be the same as the distance from this axis of symmetry to that other point. So if we calculate what is this distance, 2 minus 1 is 3 units. So this means this one must also be 3 units. So this is as good as shifting that axis of symmetry 3 units back. So minus 1 minus 3 takes us to minus 4. We can say the other x-intercept is going to be minus 4 and 0. This is by inspection. There's nothing else we can do. Okay? It's a bit rough. So what can we say then? We know that our f function is minus a half of, essentially, we're going to use the root form. So x minus the first root into x minus the second root. Okay? Then we expand. F of x is minus a half of, this is x squared, 4 minus 2 is going to be plus 2x minus 8. Therefore, f, when we distribute, we get minus a half of x squared minus x plus 4. Okay? As it was required. Okay, guys, so this is easy. This is very easy. So I see symmetry as something that can work. But the other question is, could we use the axis of symmetry knowing that the axis of symmetry is going to be minus b over 2a? That can help us to find the value of b. Then if we find the value of b, we can then substitute point B to find the y-intercept. Of course, this is going to be longer, but hey, if it works, it works. Let's put it to the test. Right. Or a student may think about that at turning point, it is such that x is equal to minus b over 2a. Right? So this is minus 1 is equal to minus b over 2 into minus a half. Okay? So this implies that minus 1 is going to be equal to, this is just going to be b. In fact, we can conclude here that therefore b, because remember this is going to be minus 1, negative divided by negative is positive. So essentially b is minus 1. Okay? We can say then, we know that our f is going to be minus a half of x squared minus x, we put it nicely, plus c. Through point B, which is 2 and 0, 0 is going to be equal to minus a half into 2 squared minus 2 plus c. So c is going to be, now this is 4, half of 4 is 2. So this is minus 2. So minus 2 minus 2 is minus 4. We transpose, it comes up as 4. Therefore, function f is going to be minus a half x squared minus x plus 4. So this one works too. Okay. Again, guys, always when practicing, do explore options that essentially can be used to do this. I'm also thinking, could we use the derivative at the turning point? Yeah, but it's only going to solve us the value of b, and then we'd have to still do this. So again, that can be thought of. But again, it's a worthy option to consider. But again, it's just 2 marks. How so sad. This is a mark, guys. And of course, writing it in that format. The rest seems to not be in interest of the examiner at all. In this one, we can say the value of b, and substituting this point seems to be what matters. And one can also think about that, but again, it was given, so I think the substitution is more important. Okay, easy stuff otherwise. Right, let's move on, folks. 5.2 says, oh, this thing filled up an entire page. Are we serious? Wow. Okay. 5.2 says we need to write down the coordinates of the y-intercept of f. This is easy. This is 0 and 4, and essentially that value there is 4. Okay. So that's easy, 2 marks. Essentially this could easily be given 1 mark. 5.3, we need the coordinates of the turning point of f. So we know that the turning point is such that we've got f of minus 1, which is minus a half of minus 1 squared into minus 1 plus 4. Therefore, f of minus 1 is, let's see, minus 0,5 into minus 1 squared, minus into minus 1, right, plus 4, gives us a 9 over 2. We can say, therefore, our turning point is given by minus 1 is to 9 over 2. Okay. Remember the question said coordinates. So no mistakes here, guys. So obviously substituting into this is good and presenting the answer in the required format. Right. So there are many ways here. Student can go about it the other way around. Say maybe the y value is going to be 4ac minus b squared, and handle the business because the x coordinate was already given. So 5.4, so sometimes we need to save a bit of time. So 5.4 says determine the equation of h, okay, the hyperbola, the straight line, which is the axis of symmetry. That's not a problem. So we know that h of x is basically minus x plus c. The gradient is always minus 1 for that negative gradient type. The positive gradient one is also going to have a plus 1. The gradient is 1. Okay, so we can use point B here, 2 and 0. So 0 is minus into 2 plus c. Therefore, c is 2. Okay, so this means our h of x is minus x plus 2. Nice and easy. How many marks here? 3, really? Okay, maybe knowing the gradient is going to be minus 1 and substituting and presenting the answer. Easy, 3 marks. Okay, so this is 5.5. We need to determine the equation of g, which is the hyperbola. Right, now we need to think about it carefully at this point. What do we have? We've got the vertical asymptote. Yeah, we don't have the horizontal. asymptote, but we can work it out because this center point here will tell us what we need there. So we can say the center of G is such that we've got h of minus 1, which is equal to minus into minus 1 plus 2, which implies that h of minus 1 is basically 3. We can say therefore that center, the middlemost point is going to be minus 1 and 3. Now that will give us the horizontal asymptote, which is y equals 3. We can say then g of x is going to be a over x plus 1. We know the value of p is going to be plus 1, right? Then plus 3. We can substitute the point here, 0 and 4. So 4 is going to be equal to a over 0 plus 1 plus 3. We can see that a is going to be, we transpose 3, we get 1. Okay, the shape is also good. It's in the first quadrant and third quadrant. So we can make a conclusion that our g of x is 1 over x plus 1 plus 3. Okay, easy stuff. So how many marks there? 4 marks. Okay, that's reasonable. I suppose getting this point is key, and writing our equation in that manner, very important. Substituting that point, and the final finish is very key. So easy 4 marks, students. I hope you are enjoying the video, and of course this taps into saying knowledge is power, guys. It really taps that into our brains. Okay, 5.6 says we want the coordinates of the x-intercept of G. Okay, for x-intercept of G, this is this point over here. So we can look for it. It is such that we've got 0 is equal to 1 over x plus 1 plus 3. We transpose the 3, we get minus 3 over 1 equals 1 over x plus 1. We cross multiply, we get 1 is equal to minus 3x minus 3. Right. So this implies that 3x is going to be equal to minus 4. Therefore, x is going to be minus 4 over 3. But remember, the question was the x-intercept. So this is minus 4 over 3 and 0. Always present the answer in the required manner. Okay. How many marks was this? 3. Okay, that situation over there is good. Okay, guys, maybe 2 marks for the coordinate pair. The rest was a means to an end. All right. Oh, I'm tired now. I'm really tired, folks. Yo, I think doing these papers is exhausting, guys. So I don't know. You better start appreciating these things a little more. But again, guys, you're doing your job, actually. You do like and share these videos. The fact that YouTube is capping these videos is not your problem, honestly speaking. It's the YouTube problem. Anyway, whatever, guys, we just continue. Sometimes it is what it is. And I'm not going to be a slave of the platform to try and get your attention. Never. You will just have to find it when you do, and when you don't, well, tough luck, if that is tough luck at all. But remember guys, there are many other channels that essentially do a great job, so you probably are aware of them, and please support those channels, subscribe into those channels. Let those guys reap the rewards of working hard to make a change. Be that change. Okay. Please also watch the ads for those who have monetized, because guys, it takes an effort to do this. For me, I take it as community service, but for others it is perhaps a way of making, an income. And this is not an easy thing to do. Please support channels that produce educational content, okay? But those that speak about Mkosi and other things, well, you decide what you want to do, but education is key, guys. Mkosi is what causes divisions and plants civil wars and hate. So for me, I am not interested in those per se. But there are those who actually do good work, even within that framework. Those are the ones that enjoy my support. Of course, mine is just a drop in an ocean, of course, but it means something at least. Anyway, folks, whatever, let's move on. We've got BSH 80, so now 5.7. See, I'm stuck in this 5.6, it seems. Okay, 5.7 starts these higher grade questions. Yay. For which values of x will g of x, what does that mean? We mean y values of g times f of x. What's that? These are the gradients of f, okay? Be less than or equal to 0. Can you see we've already had a bit of an idea here? So now we look for gradients of f. Now gradients, guys, we can portray by using tangent lines to certain sections. As we can see, that tangent registers a positive gradient, so it means the gradients are positive. Of course, from experience, guys, we know we target certain areas, not everywhere, because we're just looking for the sign, not the value. But there may be a question on the value, be very careful. So at the turning point, we know those are called stationary points, so the gradient is 0. If we do a tangent on this side, we will see that the values are negative. So this is it. Okay. So we've established the trend of tangents, or should we say gradients of f. They are ranging from positive to 0 and then negative. Now we look at y values of g. Y values of g are positive over there. And then they are 0 at the x-intercept. And then they are negative below the x-intercept. But this half is positive, is forever positive. Okay, so that's what we have. So now we need to deal with these ones. Remember, guys, how are we doing this? We take some vertical line and move it across and check, because it means for the same x value, we want y values, the corresponding y values to g and the corresponding gradients in f to give us that product. We start from left to right, okay? We go across nicely. If we park it here, for example, what do we notice? We've got a positive y value and a negative gradient. So negative times positive is negative. That's less than 0. So this is good. What happens when we get here? Still the same story. It happens up until we get to this x-intercept. Now the y values of g are 0. In fact, it's 0. While we still have negative gradients, because this is before the turning point. So that product is 0. 0 is included, so that's good. And then we get here at the turning point. The gradient is 0, but the problem is that this is undefined. It's an asymptote, so we cannot comment. We move beyond. Just after that asymptote, what do we see, guys? We see that the y values of g are forever positive, but the gradients are negative, so that product gives us what we want, a value less than 0. Okay, so this is going to be the case all the way. So essentially guys, what we have here, actually I kind of made an error. This is positive times positive, so this means it's not what we want. Okay, so this interval is not accepted, but this one is accepted. Okay, but there's a small portion here between the x-intercept and the asymptote. This is also excellent because it gives us what we want. Okay, negative y values times a positive gradient there, so that product is good except at the asymptote. So it's a very narrow area to look at, but we need to think about it. So x must be less than -1, but greater than essentially the x-intercept. So this is like that. But now let's think about it. Is it excluded? No, it is, and it is included because 0 is included. Right, or x can be greater than -1 and all the way. Okay guys, so this is easy. We get our 2 marks and our extra mark there. Right, so we've got 5.8. 5.8 says we need to determine the equation of k if k is the reflection of g about this line. This is again another higher grade question, and in the KZN paper 2 it kind of came out in the trigonometric function, but now we have it here. Okay, so yeah, I'm feeling it. Now guys, what are we supposed to do here? Now here's the most important thing. When we do a reflection of a graph, essentially across a vertical line that is not exactly the y-axis, there's 2 transformations that take place here. First is a reflection about the y-axis, right? And we're going to have a horizontal translation or shift. Okay, so there's horizontal things here, horizontal reflection as well as a translation. Now let's think about it. Where is this line of reflection? Let's make it nice and blue. Again guys, it helps to play with the tools, the instruments and stuff. So if this is 2, I can imagine 4 should be somewhere around here. Okay, so this is our line of reflection, meaning x is equal to 4. Now what are we going to do about it? We know that when we reflect a graph across this line, it means, let's take a point that is identifiable. This could be the x-intercept, or it could be anything that we can identify. For me, the y-intercept is easy to identify, or we can say the center of the graph. But for me, if I want the new graph, I prefer the center. So this center, from that center to this line, is how many units? It's how many units? Now we see that this is 4 minus the x value there. It's going to be 5 units. Now, if it is 5 units, this means I'm expecting my center to be 5 units on the other side. So it has to be 5 units on the other side of that line, because when we reflect, everything keeps a horizontal relationship in terms of distance. So if it was on the other side, it must be on the other side. So we expect our center to be here. So this is 4 plus 5. It means our center is now at 9 and 3, because we know that it's only the x values that change, but the y values don't change. But here's another thing that we need to think about, folks, is that with a hyperbola that looks like this, right? When we reflect this graph horizontally, what happens? It kind of shifts around. It looks like that. Ne? So it literally reflects like that. And now we know that it changed from, no, I'm lying. Okay, guys, so I think maybe let's just clean up a bit. It served its purpose. I don't like to clean though, because I like to work on a graph as busy as it is. Because, folks, we need to appreciate the fact that when we handle these graphs, we have to handle them as they are, okay? We need to handle them as they are. Okay, I don't need most of these other things. So let's see, this is the graph. There. Of course, guys, this process can be quite tedious. This is why these questions are to be answered after chowing most of the others. So, guys, if I just go around here, and why is it not picking my thing now? Okay, it wants me to go all around. Okay, I will. Right, so what we see, guys, is that this graph of ours, when we reflect it horizontally, first of all, it's going to do stuff like this. It's going to change the shape. But of course, it's going to be somewhere there. Okay? So it's going to be reflected across the x-axis. And then, of course, we move it all the way so that the center is seated over there. So this is exactly what is going to happen. So we can see that the numerator has changed from being positive to negative, meaning the a value. Okay? So we can write here nicely that, okay, what is this? K of x is going to be equal to, now we saw that there's two reflections that take place. I mean, there's many ways of looking at it, but if we look at that, we can just say the center. Sometimes what I do, I'll just say the center of K is such that we've got 9 and 3. So this implies that K of x is, we saw that it changes, so it's going to be minus 1 over x minus 9 plus 3. We're doing it by inspection and, of course, trying to showcase what is cooking. I do believe that's the mark. And to handle those things like that should be the extra 3 marks. Okay, very important to notice this. But what is the other way? The other way is to think about our graph being reflected essentially. Okay, I don't know if it's going to select it. Okay, it's not going to select it. It's fine. We move it there. Now, folks, if we look at it, we'll see that our graph was first reflected across the y-axis, so that our center is at 1 and 3, right? So our center there, if we can just look at it, we can think of 1 and 3. Now, we will say that this center needs to move all these units from there to there, the final destination. How many units is that? So 9 minus 1 is 8. So it means we are going to reflect it about the y-axis and then move it 8 units to the right. So we can say essentially k of x. I'm going to write this as it is. But now we're going to have minus. Remember, that's going to be the reflection about the y-axis. So we multiply the x values by negative. But within these very x values, we're shifting them 8 units to the right. Remember, originally, this is what we had. So what do we end up with? End up with k of x equals 1 divided by, when we distribute, we get minus x plus 9 plus 3. But we don't like that negative there, because we want to know what the function looks like. If we factor that negative out, we get minus 1 over x minus 9 plus 3. So therefore k of x is minus 1 over x minus 9 plus 3. Okay. So there are many ways to think about this, but as long as we know what is the target and how to get this moving, this is very important. Okay, so that's it, guys. So again, our diagram is a bit messy. I don't like to clean because, remember, students, in the exam, you only get one shot. So, but again, it's a bit messy now. This is why it's nice to annotate neatly and be able to rub off if you need to. Now the last question here says, how many marks was this? 3. Okay, to show this business in here, right, and the horizontal reflection and the final answer. Okay, very important stuff. Now let's do 5.9. Okay, says for which values of p will both x-intercepts of f plus p be greater than minus 2. Okay. This is again another higher grade question, guys. So here a student was just hit with a stone on the face. Okay, so what are we supposed to do with this? Well, what we can do is we can look, this is the graph of f shifted vertically. Now we want to know what would be the value of f when x is minus 2. So let's see, what is the value of f of minus 2? Because this can give us a guide. So this was minus a half. So we write minus 2 squared minus into minus 2 plus 4. Therefore, our f of minus 2 is, this is 4. And it becomes minus 2 plus 2 is 0, so we get 4. So we get 4. So technically, guys, this is suggesting that, remember, we found that the y-intercept here was exactly at 0 and 4. So this means it's a mirror image of the y-intercept. Maybe it's there, maybe it's not. Let's check. When x is minus 2 on this function, what do we have? What did we have there? So minus into minus 2 is going to give us 4. So indeed, it is that point. So basically, what we need is this little situation here. Again, guys, these are questions that need a bit of time to work, okay? You don't just work them blindly. So when x is minus 2, that point is basically minus 2 and 4. It's the mirror image of the y-intercept. So if we're shifting this graph vertically, so let's see, this is our graph. Okay. So if we're shifting this graph vertically, guys, if we shift it up, can you see the roots don't really become greater than -2? But if we shift it down, you can see that they narrow until we hit the root of -2. This is when we have shifted the graph of f exactly 4 units down. Because when we shift it 4 units down, the x-intercept is -2. But we want this to be greater than -2. So it means we have to shift it further such that we are sitting like that. Can you appreciate that that root is greater than -2? Even that one is greater than -2. But of course, if we shift it further down, such that the turning point is seated down, we only get one root. But remember, this thing said both roots. It means we need 2 roots. So since we're not told they should be equal, seeing that this is a parabola, would expect that we need the unequal roots. Okay? But again, we can't shift it beyond this distance of exactly the value at the turning point. And we saw that value was 9/2, which is 4,5. So this means we can shift this graph by more than 4 units down, but not more than 4,5 units down. Because in this instance, when the graph is seated like that, we actually get the roots that satisfy what we want, essentially. So exactly what we can see there, guys. So let's see what is the story now. So we will say, well, therefore, we understand that x must be less than, meaning, remember, p here is supposed to be a negative value. And this negative value must be less than, p itself must be less than 4 units, because this is supposed to be more, but since this is a downshift, that means this is a negative value. So it must be less than 4, -4, sorry. But it cannot be less than this 9,2 units down, -9,2. So we can write this like that. Okay? I don't know what happens if you say this is included, because equal roots there will be 2 and they're greater than -2, but I would rather we stay away from that because we were not told the 2 roots are equal. So if there was no indication, we can perhaps stick with what we see there. So again, guys, this is 4 marks. I suppose this substitution and that value is important, and then the notation often gives us 4 marks. So it helps to really think about these things, guys, this way. Now, what else could be thought of here? We could actually think about this as essentially f of x equals minus p. We transpose the p to the other side. So we can see p becomes a horizontal line. So we can say, well, this is perhaps a horizontal line like this. And as we can see here, where it intersects the parabola, the one root is less than -2 and the other one is greater than -2. So this one is not going to work. Again, still the same thing. That is negative. It's less than -2, so it's not working. But when we get to this point, we can see that this is exactly equal to -2 and the other one is positive. In fact, it's 0. So again, it looks as if it's gone. But if we move slightly above here, but not quite reaching the turning point, we can see that technically the root here and the root there, they are both greater than -2, but we don't need to reach that turning point. So we can think of this as a horizontal line. So the other issue is that a student may consider f of x plus p equal to 0 and say this implies that f of x is equal to minus p. But even before this situation, one can still explore what is going to be f of -2, because we really need that y value there. So this is -2 squared minus into -2 plus 4. We can say therefore f of -2 came out to be 4. We can say then we have this situation which implies that situation. So what does it mean? It means, therefore, that minus p must be less than 9/2, but greater than 4, isn't it? Because that's where that position is. And when we solve for p, nicely, inequalities will multiply by negative. P is positive. That sign becomes greater, so minus 4 comes this side. That one becomes less. It comes this side. So there are many ways, guys. Some techniques are very nice, like this technique. I think it is quite easy to understand what happened. The first one may be a bit tricky because it takes like serious understanding to know what's cooking there. But I take you through these shifts sometimes and transformations entirely so that you guys get comfortable with using any that you can see actually works, because sometimes the other technique may not be so obvious while the other one is quite obvious. Okay, so we've got here exactly 4 marks. Of course, guys, this would be the first 2 marks, and we can give the last 2 marks there, or we can distribute the marks and say the first mark is for writing that, the second mark is for the conclusion. Perhaps that would make sense, because this is a conclusion followed by a final conclusion. Okay, anyway, guys, we can clearly see that these 26 marks didn't really come so cheap at the end, but we have done our job. Okay, so let me just make myself a cup of tea and we walk through this last question. Sorry, not the last question, but the next question. All right, folks, let's move on to the next question. Question 6. Now, we are told that Matthew's dad died and he inherited the farm. His dad planned to install solar panels and already paid a deposit of 202,500 rands, which is 15% of the cost of the panels. Okay, and we need to determine the cost of the panels. Right. So what are we looking at? We are looking at, we can just say here 6.1. We can say let the price for the solar panels be X, such that we know that 15% of X, we are told that it is 202,500. So this tells us that X is going to be 202,500 divided by 15%. Okay. Therefore, X is this amount of money. So 202,500 divided by 15%. Of course, the calculators, guys, are capable of doing things. So this one says it's basically 1,350,000, right? So it's 1.3 million. Okay, right. So this is the price for the panels. Nice and easy. So this is 2 marks, okay? Perhaps the method and the answer is what matters, or even the answer only can still score 2 marks there. Right. So 6.2, we are told that the bank grants Matthew a loan at an interest rate of 9.8% per annum, compounded monthly, to pay off the balance of the cost of the panels. Right. Matthew agreed to pay monthly installments of 20,000 rands. Now the question is, how many monthly installments are required to pay off the loan? Okay. So obviously, folks, this is very important. I always advocate for a timeline, even if it's too easy. But remember, before we can get this, we need the loan amount, isn't it? The loan amount is going to be this full amount that we need to pay minus what was paid already So we know that the loan amount is going to be what we see there. So 1,350,123 minus 202,500. Okay. So basically what we have here, this is 1,147,500 rands. Okay, right. So this is the amount of the loan that Matthew is going to get. Now what I always do, folks, is to do a timeline. I always find this tool very meaningful when the situation goes a bit dangerous. Remember, at T0 we are acquiring the loan of 1,147,500 rands. And at term 1 we normally start with the payments, right? Because we were not told that there is some form of a delay. And we don't know how many of these there are going to be, but we can assume this is what is going to happen. So let's do all things nice and easy. So 9.8% per annum compounded monthly. Right, easy. Obviously, guys, we don't know if we're going to be paying this amount. Usually the last amount is not exactly the same amount. That would probably be the other equal payments. Perhaps the last one may be smaller than that. But what I like about this kind of calculation, it always corrects itself, okay? And of course, guys, I've made a video on financial maths where I looked at many different, very challenging questions. And I suppose students need to watch out for that video. I titled it, Let's Talk Financial Maths. Please find that video in the channel and watch it. Not just watch passively. Attempt those questions before you check out my approach and my solutions, and make sure you understand these. After understanding these, take a challenge of many other questions and see how well you do. It helps to do that, guys. You can't just say, okay, I'm done, I will see in the exam. That's a dangerous way of doing things. Okay, folks, let's finish this business. We know that we're going to use our present value formula. All divided by I. Right. So our present value here is 1,147,500 equals 20,000 into 1 minus 1 plus. So this is going to be 0.098 over 12 to the minus n, all divided by 0.098 divided by 12. Okay. Now, obviously, guys, when you're looking for n, students who watch my channel already know how to get this one done. We know the base is going to be that bracket 1 plus 0.098 over 12. And we know that the number is going to be 1 minus 1147,500 times 0,098 over 12, all divided by the installment. Right. So this makes life a lot easier. So we can say n is going to be what we get. So minus the log, our base is 1 plus 0,098 over 12. Please guys be meticulous, mistakes here can happen easily. 1147,500 into 0,098 over 12. That divided by 20 squared. So mistakes can happen, guys. You end up with wrong calculations and be convinced this is good. So I'm getting 77,7241. 9, just to keep as many decimals as I can. But now, guys, here's the one thing. The whole number is going to be the installments of 20,000. The 0, some change is going to be the small amount that would be the last payment. So this shows that our final payment here is less than 20,000 rands. Right. So, but now the question asked the number of installments, not of 20,000 per se. So remember, we calculate just the natural number. So n is going to be basically 78 installment. Okay, so it helps, guys, to get stuff done. So we need to understand, even if this was insignificant, we still round up because this is a natural number. It's not per se this number that we're looking at. So proper practice, guys, will help. And please watch these videos we have made for you. They will assist big time. Trust me. Okay, now let's get the marks. Nice and easy. So we know that to get our rate nicely is important. The substitutions important. Using the gymnastic is very important. Final answer, very important. So we've got 4 marks. Now we need 2 marks. Remember, to get the loan was key. Okay, could be 1 mark, could be whatever, but for me that's just what it is. Okay. So this is very important. So as you can see, guys, these are just easy marks, very easy marks. Right, 6.3 says, after 2 years, Matthew decided to pay off the loan. So he paid up until 2 years, which is perhaps this time here. This is term 24. Okay, so obviously he may have made this payment plus the final payment already at term 24. So this is when he pays off the loan. Okay. Of course, banks don't allow you to do this because it means the remaining balance is without interest. So they don't allow you to just put that money back. They would be like, okay, hold on, we need to calculate. But sometimes it's not a matter of them really being silly, but there are instances where someone has paid perhaps fewer installments, so much that when the loan is paid in full, it is way less than the one that was given. So this means the bank runs a loss. So sometimes the reason they don't allow, it's not necessarily because of being, crazy and trying to rip us off, but it's for them not to suffer a loss after giving money away and then they end up getting less, because earlier on the amount of payments put back and the remaining balance on the loan may be less than the actual amount that was granted, and so that means the bank would be suffering a loss. That's why they would be like, hold on, we're not going to allow you that, at least go on maybe 3 more months, 6 more months or so that at least they can make back their money and with some interest. Okay, but sometimes it's all the chicanery. We know that in the majority of cases it's the chicanery, but yeah, but sometimes they can be undercut, you see. Anyway, so let's see. It says determine the balance of the loan after 2 years. Okay, that's easy. Remember, the balance is the balance outstanding, guys, on the borrowed amount, basically. That's what we need here. And so this means we need to consider this interval. So obviously, how many terms are these? We calculated 78. Now, if we don't count that payment, in fact, we need to count that payment, but of course, it's already been made. So how many payments remain? It's 78 minus 24. So this is going to be 54. Yeah. So there's 54 payments still needing to be paid. So this means Matthew, by paying off the loan after 2 years, he will avoid 54 payments that would have gone with interest. So he avoids a lot of interest in a way. Okay. Obviously, guys, we just use our present value here. We know that our present value is x is into 1 minus 1 plus I to the minus n, all divided by I. Okay. This implies that the balance outstanding here is going to be 20,000 into 1 minus 1 plus 0,098 over 12, all to the exponent minus 54, the remaining payments. Okay, so this is divided by 0,098 over 12. Okay, so therefore our balance outstanding after 24 months, what is it gonna be? So let's see, this is 20,000 into 1 minus into 1 plus 0,098 over 12. Again, guys, we need to be meticulous here. Things can go wrong with incorrect substitutions, and that can be a nightmare. All right, so we get a balance on the loan of 870,499 rands 45 cents. So money is to 2 decimal places. So this is the amount that the man still holds from the bank. But remember, this one is without interest at this point in time. So if he pays it back, so he pays this without interest. That's if the bank allows him. Easy stuff otherwise, guys. So again, the exponent here is very important, the substitutions, and the final answer. Nice and easy. 6.4 says, calculate the total amount paid for the panels. Okay, the total amount, remember, it's going to be this balance outstanding plus those 24 payments that have been made. So let's see, we know that the final amount or the total amount paid is going to be 24 payments of 20,000 plus the 870,499 rands 45 cents. Okay, therefore the total amount paid Remember, this is money, the symbols must be right. So just take that and say plus 24 into 20,000. So this one is 1,350,499 rands 45 cents. Nice and easy. Okay, so technically he didn't undercut the bank in a way because he borrowed 1,147,000. He's paying 1,350,000. That's already more than he was given. So the bank may allow this, essentially. Okay, guys, so this is cool. So this is very easy questions, essentially. Please, guys, focus and listen to the line of questioning and ensure that you understand the question as it is given. All right, so make sure you limit the amount of mistakes. So this is good, the substitutions and the final answer. So this is otherwise an easy 14 marks. Okay, easy peasy lemon squeezy. Okay, let's do differential calculus now. This is where students can score easy marks effortlessly here. Right, so 7.1, we are given f is x squared minus x plus 3. We need to find the first derivative using the first principles. We know that f prime of x is the limit as h tends to 0 of f of x plus h minus f of x all divided by h. So this implies that our f prime is the limit as h tends to 0. Now we substitute. Where we see x, we put x plus h all squared minus into x plus h plus 3 minus the entire f of x all divided by h. So this means our f prime of x is going to be the limit as h tends to 0, we expand. So this is going to be x squared plus 2xh plus h squared minus x minus h plus 3 minus x squared plus x minus 3 all over h. So the magics take place. If they don't take place, there is a problem, okay? But again, we simplify systematically. F prime of x is the limit as h tends to 0 of 2xh plus h squared minus h all over h. F prime of x is the limit as h tends to 0. We take out h conveniently so that we can get to business. Again, the magics need to happen. If they don't happen, something is wrong. So f prime of x is going to be the limit as h tends to 0 of 2x plus h minus 1. This also implies that f prime of x is going to be equal to 2x plus 0 minus 1. We drop the limit at this stage. So f of x comes up as just 2x minus 1. Even when we use our power rule there, it still holds true. This is what we expect. So it means our stuff is good, guys. So substitutions into the formula, it's a mark. Simplifying all the way until there, that's a mark. Factorizing, it's a mark. Substituting here by dropping the limit, that's a mark. And the final answer. So easy 5 marks, folks. This is a gift from the examiners, honestly speaking. All right, let's do 7.2. 7.2 says we need to find the first derivative of these functions. If we look at the first function, this is ready for differentiation, so we just go for it. So if we've got f of x is equal to 5x cubed minus 7x plus 2, we know that the first derivative is going to be 3 by 5 is 15x squared minus 7. It's done. So obviously we get a mark for those derivatives. Nice and easy. Then we've got 7.2.2. If we look at our f here, f is not ready for differentiation. So we need to start doing some things. This is the cube root of x, okay? So we know that our f is basically 2x plus 1 divided by, we first convert that into exponential form. So we get that rational exponent, right? Inverse operations, inverse operations. So f of x equals 2x divided by x to the third. Remember that denominator divides each one of those terms in the numerator. Again, you can call it partial fraction decomposition. This is at a basic level. Sometimes it can get hot. I've shown you though, guys, in trigonometry lessons how to do partial fraction decomposition. That's another thing that needs to be understood, especially for college level. Right. So this one is not yet ready, because our variable with which we are differentiating, or with respect to which we are doing the differentiation, is in the denominator. So this is this thing now. 1 minus a third is going to be what? 2/3, isn't it? Using exponential rules. My lord, this doesn't look so nice. In fact, it's going to clutter. We need to present our answer in the most neat way possible so that it's easy to read. So this is going to be x to the 2/3, because it's going to be 1 minus the exponent in the denominator plus x to the minus a third. Okay, that one is easy. Now we are ready to differentiate. So f prime x is going to be 2 over 3 x to the minus, now 2 over 3 minus 1. You see, that's going to be minus a third. Minus a third of x to the minus 1 there. This gives us minus 4/3, isn't it? Let me check and be sure. Yeah, that's good. That's good. 2/3 minus 1. It's minus a third. So this is good. Essentially, guys, I prefer to leave it here. The issue of changing to exponents and radicals is not necessary here. So for those two derivatives, we get a mark. For writing our expression nicely, that's a mark. Converting to exponential form, that's another mark. So easy 11 marks, guys. This is a gift from the gods, if you believe. But if you don't, it does not matter, comrades. It is what it is. Okay, so let's move on, guys. Cubic function. So this is question 8. Right. Question 8 says, the graph of f is x cubed plus bx squared plus cx plus d is sketched below. And we can see there's only one real root here. So what does that mean? It means our quadratic factor, perhaps this portion, if we think about it somewhat. But of course, it's not exactly directly what we see there, but it means our quadratic factor there has irrational roots, okay? Right. So when that has irrational roots, what does that mean? This is a mother function. I don't believe it. It means, no, not that this has irrational roots, but what this means is that if we have only one real root, it means the quadratic factor of this expression is irrational, okay? But the first derivative does have roots because it looks like it's turning at a and b, right? So that's what we can see. We're told that a and b are the turning points. If they exist, therefore the first derivative has real roots, but the factor is irrational in the original expression. Okay, now we're told that f prime of x is greater than 0 for x greater than 2. So it means that point of reference is the x at the point of inflection. Okay, so already this means the graph changes concavity. Perhaps 2 is over there. It's usually the average between the two x values at the turning point. So this is suggesting that, okay, all right, okay, so this is what we have for now, this being our point of inflection. Right. Now we're told also that the line y equals 20, and we can see this is a horizontal line, is a tangent to f at x is equal to 1. Now, if this is a horizontal line, this means it's a tangent at the turning point. Right. Right. So we can see that if we already have 2 here, this means this is the tangent at a, the turning point. So this means this is 1. So a is 1 and some y value. The good thing, this is a horizontal line, so this is 20. So this is giving us the coordinates of a indirectly. Okay, that's cool. All right, so that's it for now. That's all we can say. And the good thing is, if that's the case, we can also tell what the coordinates of b should be, at least in terms of x. Remember, the distance from that to the turning point, to the point of inflection, is equal to that distance. So this is basically 1 unit. So this is going to be 3 over here. So b is basically 3 and some y value that we need to figure out at some point. Okay, cool. Anyway, we are ready to hustle this thing. We have done our part. Okay, let's start flexing. So 8.1 says we need to find the values of b, c, and d that they are like that. Okay, what do we have, guys? Whew. We know that the first derivative at the turning point is 0. So we can derive some simultaneous equations there. The gradient at the turning point is 0, so we can do that, and we know that this is when x is 1. So when x is 1, we know that the first derivative is 0. So we can derive an expression there. The second one that we can do, to seeing that this is the x-coordinate at the point of inflection, this means the first derivative, the second derivative of f when x is 2 is also going to be 0, right? And that can help us to solve something. Now let's do this business nice and easy. So we know, guys, that we were given f of x as x cubed plus bx squared plus cx plus d. But take note, the coefficient of the highest power there, it's an invisible one. So it concurs with the shape of the graph. Ne? So what do we need, guys? We know that we need the first derivative. This is going to be 3x squared plus 2bx plus c. Alright? And we need the second derivative. This is going to be 6x plus 2b. Okay? Now this is very important to always do, okay? Because we know we're going to need each. So we can say, but what do we know? We know that the second derivative when x is 2, this is going to be 0. We know that this f double prime of 2 is equal to 0. We know that's the point of inflection right there. So this means 6 into 2 plus 2b is 0. Implies 2b is equal to minus 12. Therefore, b is minus 6. Kitchen. Done. You can say also, we know, folks, that f prime of 1. Also, f prime of 1 is equal to 0. We knew it. We knew it. This implies that 3 instead of x, we put 1 there, plus 2b into 1, plus c is equal to 0. So we move on. Essentially, we're going to have 3 into 1 squared plus 2. Instead of b, we put minus 6 into 1 plus c equals 0. Therefore, c is going to be, let's see, what do we get? 3 minus 12, right, is minus 9. So when you transpose this, c becomes 9. Right. So, very interesting question there. So that's what we get, guys. We can say then, we know that f of x is basically x cubed minus 6x squared plus 9x plus d. Now, what are we going to do? We know that the coordinates of a, this question is crazy, is it not? My goodness. It's a very crazy question. I think we need to state the coordinates of a. We can say point A is the point 1 is to 20. Right, this is the point tangency, the port. Right, okay, easy stuff. So we know that with A as 1 and 20, this is going to be, this is going to be 20 equals 1 cubed minus 6 into 1 squared plus d. Therefore d is, so we're going to take 20, subtract the sum of these, 1 minus 6 plus 9. We get 16. Okay, so this is done, guys. We found all those variables. Okay, nice and easy. As you can see, guys, this is one of those killing questions. So we're just thrown with a stone from just the very beginning. Standard grade students would struggle to figure this out, but hey, you have to deal with it, unfortunately. So let's see, guys, what is the story here? We're supposed to score 5 marks, so I think the differentiation here and the substitution is cool. Yeah. Anyway, guys, I think this point is key in the process. Essentially, again, this business there is good. Okay, maybe even down here when we do the substitutions for and substituting the point. I mean, it's quite vague, but if everything is in order, guys, we get full marks no matter what. So 8.2 says, for which values of x is f strictly decreasing? Now, when it is strictly decreasing, we mean it must have negative gradients. Okay, so negative gradients are only here in this section of the graph. So between the two turning points. So this is good. So we can just write x must be less than the value at b, which is 3, greater than the value at a. That is when the graph is strictly decreasing. At the turning points, it is neither decreasing nor increasing, so we cannot include them. So this is 2 marks. Obviously, guys, this mark is mainly for that dude and the overall inequality. Finding that 3 was key, and we can see we did it by inspection, so we don't need to explain. Easy stuff. So let's get to 8.3. Now 8.3 is again one of those higher grade questions. Right, we can already see we are told g of x equals mx minus 16 is a tangent to f. Okay, we need to determine the value of m. 6 marks. Okay, let's see, what can we do here? If this, oh god, this thing, if we look here, we see that the y-intercept of our tangent is negative. So it's not possible to be anywhere but perhaps here. The tangent can only be on this side for it to cut down there, you know, at minus 6. No, minus 16, if this is minus 16. So this is the likelihood of the point of tangency, POT, with x is to y, which we don't know. So that's the only place, because everywhere else the y-intercept would not be negative. Only in that segment we would have negative y-intercept for the tangent. Okay, but does that 16 help us in any way? What does 16 help us with? Haritz, is it useful? Oops. Come on, guys. We were cruising nicely. Now, what is this? Now, what is the meaning of this? Now. What is the meaning of this now? Aye, it's not good, man. Alright, so what are we gonna do, folks? You see, I wish this was a plus 16 because it would mean this one right here. We would have a nice point. Are they not trying to say that though? But you see, this one is negative. Is there no error? Because this looks impossible. Okay, maybe not impossible, but I can't immediately see what to do here. Okay, but anyway, at the point of tangency, one thing we know for sure. We know, okay, let's introduce it. Like this is the port. Okay, we know that the first derivative of f is going to be equal to the gradient of the tangent, which is m. We differentiate. Okay, we forgot to write our f. Excuse me, guys. We know that f of x is x cubed minus 6x squared plus 9x plus 16. That's what we need. And then we can say our stories nicely now. So at the point of tangency, we know that the first derivative here is going to be equal to m. So this is going to be 3x squared minus 12x plus 9 is equal to m. But it's not a lento. It's not a nini. Because you see now we don't know the x value. So if we were to know the x value at the point of tangency, at least we would be able to cruise. Hence I was kind of hoping and wishing that we were given that tangent there. But if we look at the y-intercept, it's not possible to be there. Is there an error with this question now, guys? This thing is percussing me now. You see this question, you just look at them from a distance and you think, this one is easy. It's not so easy now because I can't move, I'm stuck. Is this minus 16 supposed to help me though? What does it help me with? But you see, the problem is that, if we substitute, if we equate this to the cubic function, we're going to run into problems, are we not? But this is cubed. We might not be able to solve, you see. Yeah, ne? Remompieng bianong. Rebompieng wabon. Ulaba bedlaniye. Mina nilaba kuchinayo. This thing is doing things now. What is it doing? What is it doing? What is it doing? Ash. Yikes. I wish my students were here. Maybe we're doing a live lesson. I know those guys are smart, man. They just know how to come up with answers, Because when I get lost, they show the way. Again. Because guys, if we equate this to the cubic, because we know that at the point of tangency they are equal, but how does that help us? Because this is already a disaster, and that thing is also a disaster. Because we know that f is equal to g of x. I mean, at the point of tangency, there's two things. We've got equal gradients and they share the point, but we don't know anything about that point. Okay, guys, when you get to these kinds of questions, just jump the thing, okay? Just jump it. Because it's really chowing us big time right now. When I'm going to into another question, go. You know what I often say, guys, when you get to these kinds of things, sometimes you're not sure. As I said, think of what would work and use it, because chances are, in the next exam, if this question comes, it may be that the tangent is where we can work nicely, you know? Because this one is already down and out. So what can we do? We're only in trouble if a similar question is created and we haven't seen how it's done. Yes. Excuse me. Now I'm pitegile, guys. Anyway, let's just play some algebraic things and see what happens. We can say also, I'm not sure, guys. This may work, may not work. If it doesn't work, say it's about a question. We are passing it. We are jumping it. Because you know what, guys? Sometimes you never know some mysterious things. So what I'm thinking, I'm going to try to play an algebraic trick and see what happens. We're going to say we also know that also at point of tangency. Okay, maybe we stated it nicely. So we can say also, because I mean, those are the two things we know happen at the point of tangency. At the moment, we don't have enough information to find that point nicely. Let's see if algebra is not going to be useful here. So what do we have here? X cubed minus 6x squared plus 9x. Yeah, guys, come on. What is this? What is the meaning of this now? If we do this, what happens? I mean, but you see the problem is that if we incorporate this to that side, 16 goes to 32. This will go to that, so it's literally going to be 9 minus m. But you see the problem, this is cubed, so we won't be able to factorize. Yes. Yeah, but sometimes, guys, you write these things and you leave it here, okay? Just move on. Sometimes you're gonna get marks. At least for your efforts. What can we do? What can we do? Maybe 2 marks nyana there for the two equations equaling each other and then the first derivative. Yeah. I'm not so sure anymore if I like this question. Now we know our provincial papers have a tendency to have, they have a tendency to have errors. Is it possible that that was meant to be plus 16 perhaps? I don't see what we're gonna do here, guys. I don't see, unless we can express m in terms of x, then it can help us somehow. Let's just play. In fact, let's try and do this and say, since we've got m in terms of x, let's substitute that in the place of m and see what happens. It may work, it may not work. You see, guys, sometimes algebra, this is why I always tell you, be able to face algebra as it is, because, I mean, questions like this just take away the morale. because they're telling us we're going to suffer. Instead of m, let's put 3x squared minus 12x plus 9. Maybe we're going to win, maybe we're not. But if we get stuck, guys, I'm a die-hard though. But I'm a bit scared. By the way, this was meant to be x times x. Ne? This was times x. Okay. All right. All right, let's see. Yeah, sometimes algebra, guys, is the best way because at least we're not told to use the graph, you know, things like that. So this is 6x squared plus 9x plus 16 equals, we distribute here, we get 3x cubed minus 12x squared plus 9x minus 16. Yay, run away. So we take this to the other side, or in fact, let's take this side to this side. So 3 minus 1 is going to be 2x cubed minus 12x squared plus 6x squared is going to be minus 6x squared. The 9's go away. The 9's go away. And then the 16 we get minus 32 equal to 0. Okay, this can divide 2. Let's see, Ayman, don't go. This can divide 2. We get x cubed minus 3x squared minus 16 equal to 0. Now we need to try and factorize this thing by what you call, because honestly this one is going to give us two values perhaps when this graph intersects this graph again, because remember it is only a local tangent there. It's not a true tangent. Sometimes I hate this word when we say a tangent, but perhaps we should say at a particular, in fact a local tangent at a point, because you see it is effectively a secant on this function. Maybe we might get something. If it makes sense, we get a point where the x is negative and where the x is positive. And I think we're on the right track. Let's see, when will we get 0 here? 1 is not going to work. Let's say 2. 2 cubed is 8. 4, that's 12. But now 8 minus 12 is not going to help. How about 3? 27. 9 by 3, that's 27. It goes away, it leaves us minus 16. Yes. It's never, come on. How about minus 2? This is going to be minus 8. And this is going to be minus 12. So minus 8 minus 12. It's going to be a lot. Minus 8 minus 12 is going to be minus 20. Minus 20 minus 16 is not happening. Let's check minus 3. This is going to be minus 27. Right? This is going to be minus 27. Hi, man. Hey, hi, Yango. Did we do the right thing here? You see now this thing, guys. I knew this thing is gonna give us a nightmare. Anyway, let's just go to the what you call the mode. The calculator sometimes can help. You go and choose equation on mode, and the last one, number 4, is the one like this. So A is 1. We press 1 and say equal. B is minus 3 there. C is 0 in here. We need to account for that. D is minus 16. Okay. we get 4. Okay, wow, I didn't think that 4 is gonna work. So if 4 is a factor, so this implies that we've got x minus 4 as a factor here, right? Because my x1 is a 4, my x2 is irrational and all, so x3 is also irrational, it's negative. Okay, yeah, the other one is minus 0,5 plus 1,9 whatever, so it's negative at least. Yeah, it's all negative stuff, so I can accept this. I can accept this. Yeah. Now let's try. To get 16 we need 4, isn't it? This must be plus 4. Now we can focus on the middle term. We want 3x squared. Oh, sorry, here we're going to have x squared. Now we want 3x squared to come out. So what must we multiply there? So this is minus 4x squared. Then this must be plus x squared. Plus x. So that we've got x squared minus 4x squared. It gives us minus 3x. Does it kill this one? Yes, it's going to be 4x minus 4x. It dies. So at least we've got some factors. Hey, nansi into indaba na indaba la. But let's see. This function is a parabola, right? And this parabola, if we think about it on the Cartesian plane, again, this is the essence of knowing how to look at these graphs, guys, and imagine what the graph looks like. Because I'm lazy to be doing too many calculations right now. By just inspection, I know this has a positive y-intercept, whereas the middle term is positive and the first term is positive. So it means my axis of symmetry lies to the left of this thing. So this means our graph is doing stuff like this. Right. Okay, it's doing things like this. So I know that my graph is like this because my axis of symmetry is to the left and we've got a positive y-intercept of 4. I'm talking about the parabola. So this is already suggesting that it's going to have negative roots. So that means I don't have to worry about the values that come out because they would kind of speak into this business right here. And we are only interested in the positive one. And again, we see that we already have 3. So, it makes sense that this should be 4. I can accept that. Okay. Wow. Yeah, anyway, guys, once your algebra is strong, though. Yeah, but this is very tiring. It just doesn't appetize, I don't know why I didn't think about this already. Anyway, as long as it worked, we can say therefore x is equal to 4. So if x is equal to 4, we can say then we'll leave the others because that's not possible. On the negative side, we can't have a tangent with that situation, so it's not going to work. So we can say then m is equal to 3. Instead of x, we put 4 squared minus 12 into 4 plus 9. I wonder if students got this one, but I'm not convinced that the guys got it. But hey, it's easy to underestimate these dudes, but these dudes are brilliant. Remember, they're not as distracted as I am. So I'm getting 9, guys. Okay, it's a fairly steep gradient, so can accept it. It makes sense. At least the x value at the point of tangency makes some sense, and we can find the corresponding y value if we want, but I don't think at this stage we need it. We've already taken a lot of abuse here. All right, so we've already taken some abuse, so I'm feeling like, no, let's limit how much we want to do. Okay, let us limit. Okay guys, so yeah, this one was not nice. It was not nice at all. And again, these are the time wasters, guys. You just move on sometimes. Anyway, let's see. We can say this is a mark to take the first derivative and equate it to m. Right. Maybe this step, also important. Factorizations, getting what we need and finding the x value and finding that. Perhaps this one too, just to make up the 6 marks. Okay, it's a bit crazy, but it is what it is, guys. What can we do? Yeah, this one was a destroyer. We can even give it 2 asterisks. Hi. I'm sure the kids dropped these ones. But again, guys, I've shown you how to survive issues, as you can see. But just trying your luck sometimes, of course, in an informed manner. Yes, it may work. Sometimes it may overwhelm. You never know. But what do you do when you have nothing better? So yeah, this question was, ooh, I am telling you. So please be mindful of questions like this, because it's already highlighting something that if we can express something by another variable, we can actually do some algebraic issues here, trying our best to be as meticulous as possible. Okay, this was rather a challenging 13 marks, especially the last one. It's easy for students to drop all those 6 marks. As you can see, it took noticing that this point is over there, and from there, yeah, noticing that it's going to be a point ahead of 3, so to speak. Yeah, I've got a lot of things to consider there. Anyway, guys, it is done. So let's get to question 9, optimization. Question 9 says, the rough sketch graphs below represent the distance covered by each of the 3 athletes, Ben, John, and Chris, in a marathon race of 80 kilometers at different times from the start of the race. The y-axis represents the distance in kilometers, and the x-axis the time in hours. Okay, cool. So the following equations represent roughly the movements of the 3 athletes. Ben is the straight line equation. Okay. Ben is this one. All right. So John is the parabola. So this is the quadratic function. Okay. And then Chris is the cubic one. So this is the one. Okay. So we are told that the total distance is 80. So these are very restricted graphs. So basically, this page kind of shifted around, so it kind of misaligned. So we may have to try and get these graphs there. Okay, so these graphs are restricted right there. They are restricted. Very restricted, okay? Okay, I'm very tired now, guys. So, essentially we can see that these guys finished the race at different time intervals, okay? But they each moved the same distance. Okay, cool. So this is the story there. Alright, so that's what we have over there. Great, great, great. Anyway, so the restriction here, we know that x is less than or equal to some value, but greater than and equal to 0. For each one of these graphs, of course, the x value to the right is different for each, okay? Right. Anyway, let's move on, guys. What are we gonna do here? 9.1, it says, which athlete was leading after the first hour? Of course, it's the one that's gonna be ahead in terms of distance. So if we draw a vertical line, if we draw a vertical line at 1 hour, what does it look like? We will see that, okay, all right, okay. The distance for h is greater than the distance for f, which is greater than the distance for g. So it means it's going to be that guy. It's going to be this one. Okay, K, that's Chris. So we get 1 mark, nice and easy. 9.2 says, which athlete completed the race in the shortest of time? This is going to be this guy who finished first. It's G, the parabola. So that's John. Again, we get just 1 easy mark. And then we've got 9.3. It says, during the race, Chris slowed down to drink water. So Chris is K. Determine after how many kilometers Chris ran at his slowest speed. Now, if you look at this function of Chris's, it doesn't seem to have turning points. This is somewhat horizontal, okay, at this level. So this means, essentially, right around this point, we actually have a point of inflection instead. We don't have turning points, but we do have a point of inflection. And the question now says the distance traveled. After what distance did this guy travel? So this means this is the question that we're looking for. Perhaps the corresponding y value of the point of inflection. And this looks like the mother function. Well, how do I know? Let's see. If we do the first derivative function, it's going to be 3x squared minus 10,5 by 2 is 21x plus 37. Now if I look at this, I know graphically, again guys, by graphs you can already see what type of roots we are going to get here. Graphically, this is a smiling parabola with a positive y-intercept, and the axis of symmetry is to the right. It's to the right. Okay, cool. But now, question is, does it have roots at all? Let's find out. If the discriminant is less than 0, it's not going to work, right? So we've got minus 21 squared minus 4 into 3 into 37. The discriminant is negative, so it does not have roots. So this is the graph that does stuff like this, so to speak. Okay, again, it helps to check the discriminant to see if the roots are actually okay. And if they're okay, we know that they were supposed to be positive. But you see, this is already suggesting that if our first derivative function does not have real roots, it means this is the mother function. So it only has a point of inflection. So we need this x value. From getting this x value, we can get the corresponding y value. Wow, this is a higher grade question, guys. This is a higher grade question, guys. So we already treated this with my students. So this is more of a repetition. Very interesting stuff. Okay, cool. And we're told that Chris actually never stopped during the race. Okay. Yeah, the point of inflection is just an instantaneous changing period, so to speak. Of course, the gradient is the smallest there. At this point, it's 0. Okay, guys, so we know that for us to find the x value at the point of inflection, we need the second derivative. So we can start by saying k of x is basically x cubed minus 10,5x squared. Plus 37x, right? Right. And we can say k prime of x is going to be 3x squared minus 21x plus 37. Then we can say k double prime is going to be 6x minus 21. We can say here at point of inflection, the boy, it is such that the second derivative is equal to 0. This implies that 6x minus 21 is 0. Therefore, x is going to be 21 divided by 6. This gives us 7 over 2, which is 3,5 hours. Is it minutes? It's hours, yes. So that's hours. Now, we are looking for the corresponding y value. We can say then, we know that k of 3,5 is going to be 3,5 cubed minus 10,5 into 3,5 squared, which means that k of 3,5 is equal to, let's do it. So we've got 3,5 cubed. Yeah, there's a lot of calculations here. 10,5 into 3,5 squared plus 37 into 3,5. So this gives us a 43,75 kilometers. right? Now that's what we were looking for. So we can say, therefore, Chris Chris ran at his slowest speed. You can say Chris ran slowest because remember the rate of change is the gradient here. Chris ran at the slowest speed after a distance of 43.75 kilometers. We must always answer the question, guys, in full. In English, or in the English class, you guys are taught how to answer. So please answer properly. Right, that was something else too, okay? Right, folks, so what is important to get our 5 marks? I would suppose getting our second derivative and equating it to 0 and getting that and substituting and answering the question. And certainly the first derivative was also important here. But again, one can give 2 marks, left hand side, right hand side over there. But I think before we can get to the second derivative, we must have found the first derivative too. So this is essentially 3.5 hours over there. Okay, guys, cool. Very nice question. Let's go on. So we've got 9.4. It says, at what time during the first part of the race were John and Chris the furthest apart from one another? Okay, the first part of the race. So now what will give us an impression of the first part is before Chris took some drinking there, right? So because the first part was explosive, so we can say perhaps the first part is up until the point of inflection for Chris. And now we want to know, in this first part, we wanted, so it says, at what time during the first part were John and Chris the furthest apart from one another? Of course, this is the vertical distance. The vertical distance between them. So this is going to be something like here. So we want that distance between them. So Chris is ahead and John is trailing. Okay, so we know that we're going to say let, in fact, let's do this below because it's going to be quite a lot. So 9.4, we can say let the distance between them be capital letter D, okay? Such that D is going to be equal to K of X minus G of X, okay? This implies that D is going to be X cubed minus 10.5 X squared plus 37X minus, this is 2.6 X squared. Therefore, our D is going to be X cubed minus 10.5 plus 2.6 gives us a minus 13.1 X squared plus, see this right here, Mistakes, guys, they creep in when you are tired. It always happens. So we've got this. Now remember, we're saying this furthest. Now furthest means it means maximum. So we can say for maximum distance to be such that dd over dx must be 0. Yes. So this means 3x squared minus that times 2 is what? Minus 26,2x plus 37 is equal to 0. And obviously, guys, we just need the quadratic here to solve for x. We know that x is minus b squared minus 4ac all over 2a. Okay, so this implies that x is going to be minus into minus 26,2 plus or minus the square root of minus 26,2 all squared minus 4 into 3 into 7 all divided by 2 into 3. Again, guys, we think about this. What are we expecting? Of course, if the discriminant, I hope the discriminant is not negative. If the discriminant is not negative, so we expect a graph like this. Okay, guys, I cannot overly emphasize this, honestly speaking, because I need you guys to be sharp when it comes to these things. This is why I keep doing them. I know that my axis of symmetry is going to be to the right of the y-axis. So our graph is going to be stuff like this. It's going to have positive roots, if at all the discriminant exists. But let's see what happens. So we expect two positive values here. But now we will decide which one to take. Right. So this is minus into minus 26,2 plus the square root of minus 26,2. Oops, you see now. Wrong substitutions. Yeah, guys, sometimes it gets to you. It gets to you. I wouldn't blame you. These guys are too outrageous. Here, look. So many hard questions. But yeah, this is a math exam, guys. You gotta suffer. So we're getting x is 6,96. Remember, this is ours. Or we expect a positive answer. Now we don't know which one is which. Let's find out. Okay, we get 1,77 hours. Now, remember, we were told that this is the first part of the race. So first part, this is before the point of inflection. So it's going to be that small value there. All right. So we can say, therefore, our x is going to be 1,77 hours. We can say, therefore, they are the furthest apart at 1,77 hours during the first part of race. Okay, please, folks, answer nicely. Present the answer with confidence and enthusiasm. Yes, it's torture, but what can we do? We have to do it. So this is an optimization question. Of course, guys, I'm going to give you a video where I treat some of the very interesting optimization questions using different, mathematical standpoints, so that you guys can be comfortable dealing with whatever comes. As you can see here, we dealt with graphs instead. So it can be graphs, it can be shapes, it can be, issues of rates of change in terms of speed and distance, like it is the case here. So we need to know those things. So what do we do, folks? Yes, extracting that issue there and equating the differentiated distance to 0. That is 3 marks, folks, and substituting into the quadratic formula as a result. That's the 4th mark. Are you for real? So it means differentiation here together with equating to 0 is not good enough. But again, the quadratic formula is being applied, so it may be ignored. The final answer, 4 marks, but this should have been 5 marks. There are some marks that I feel were not supposed to be given up there. This one was really worth 5 marks. Anyway, guys, as we can see, if we understand our work, there's nothing really that destroys us. So we move on. Okay. Now, how many marks was this? 11 marks. Okay, perhaps the last 9 marks takes us a bit of time as well as thinking. Now let's get to question 10. Guys, this is the section you are never to approach, tired and under pressure for time. Please never do it. So essentially, I've given you guys very nice videos on these topics. Probability, building you guys from grade 10 stuff all the way to metric higher grade questions. And of course, I was helped by that document I found from the answer series. And then, excuse me guys, I think I'm getting tired of this business. And then, of course, guys, the fundamental counting principle, because these topics can be a headache, okay? I promise you. Anyway, let's get going. 3 events A, B, and C are represented on the Venn diagram below. A and B are independent events. So it means there is an existence of the intersection between the two. It is not equal to 0. Once they are independent, that intersection exists, okay? Great. A and C are mutually exclusive. Well, we can see A and C do not intersect at all. So we know that this means the probability of A intersect C is indeed 0. Now, P of A is 25. But you see, A is this whole little field. So that's 0.25. But remember, there's an intersection between A and B. So there is an intersection. So we can't fill things in just yet. All right. So again, P of A or B, what is that? P of A or B is basically everything in B, right? Everything in B, the intersection between B and A. So this is essentially saying all the fields of A and B, including their intersections. But we can see that B would also take the intersection with C. So that is the statement that we are given here. Okay, so it helps to understand exactly what component or what portion of the Venn diagram is being represented by the given information. Then we're told X lies outside P, A, B, or C. And we can see there's our friend there, the standalone guy. Okay. Right. So first question says we need to show that the probability of B is 0,4. So we're going to use the addition rule there. P of A or B is going to be P of A plus P of B minus P of A intersect B. We substitute, so this is 0,55, this is equal to 0,25 plus P of B minus. Remember, when the events are independent, it means this is going to be the product of their probabilities. I don't know what I'm doing there. Times P of B. So this is what we have. Nicely, we only have one unknown, so this is good. So P of B minus 0,25, what is it? 1 minus 0,25 gives us a 0,75 P of B equals, so we're going to say 0,55 minus 0,25 is 0,3. Okay? So therefore, P of B is going to be 0,3 divided by 0,75. This is indeed 0,4. Okay, that was asked rather, in a tricky way. Anyway, folks, we're getting 3 marks. So I would say perhaps capturing the fact of independence and the general substitutions in the final answer is key, but sometimes just constructing the addition rule in terms of A and B could be considered for the 3rd mark. Okay, so 10.2. We are told to calculate the probability of A and B. So P of A intersect B is going to be the P of A, which is 0,25 times 0,4. So what do we get? So 0,4 times 0,25, we get 0,1. Remember, folks, we don't know the instructions, but if the general instruction says 2 decimal places, then we need to add extra digits there. But for now, since we don't know what they look like, we can cut the corners, but be very careful. We're not doing this general, we're just doing it here because we have nothing better to do, okay? So again, guys, substitutions and answer, this could have been just 1 mark. This mark belongs up there in the optimization question. But again, guys, sometimes marks are not given in full so that sometimes the examiners know that they expect students to struggle in a particular question. So to minimize losing a lot of marks, sometimes strategically the marks are actually made to be less. Okay, to avoid students failing the paper dismally. All right. So 10.3 says, If P of only C is 0.25, now only C is this one. So only C is just that part, okay? And we're told that the probability here is 0.25, okay? Now we need to find the value of X, okay? Easy. Now already, guys, we know the probability of B as a whole is 0.4, but that includes the intersection. So we can actually see now that if we fill that thingy in, that's 0.25 minus basically 0.1. So this means A only is going to be 0.15. B as a whole is 0.4, including the intersection. So, yeah, we've got our stuff sorted. So we know that essentially, guys, P of the sample is supposed to be 1, isn't it? So all we can say is X is going to be 1. It's a complement of all these things. So it's 0.15 plus 0.4 plus 0.25. Therefore, X is, we add here, plus 0.4 plus 0.25. Then we take that from 1, we get 0.2. Okay, this means X is 0.2. Okay, guys, using complementary events here, that's just the stuff. Okay, yeah, guys, these things are tiring you. Too many questions, man. If it is further given that P not A and not C is this one, so what does that mean? Not A and not C basically means this. All right, folks. So this is what this is. So all the shaded area is not A and not C. So this means it's the portion of B and the outside, basically. So we need to calculate the probability of only B. So this is easy. So 10. Damn it, Wennerman. So this is 10.4. So essentially P of B only plus X is going to be equal to the P of not A and not C, right? So therefore P of B only, not P of Bonley though. It is not P of Bonley, ne? P of B only, ne? This is going to be basically 0.38 minus 0.2. So this is going to be 0.18. Ne? All right, so guys, that is the probability of B only. So again, these are some questions that can challenge a lot, but I think I delved as very deep as I could in the video on probabilities. Please, guys, that video I will certainly not repeat. I can only answer some specific questions, but I won't do questions like I have there. So use that video to elevate yourself to a position where you can still score marks despite the challenging nature of this topic, but it is again a very useful one to master as well. Right, so this is nothing but an affordable 9 marks, isn't it? Yeah, we can afford that since we have done the crash course nicely. Okay, this page was a bit of a mess. So let's get to the last question, guys, and stop this nonsense. There's nonsense. Okay. Examination numbers for the grade 12 learners final examination are determined in the following way. The first digit is the province number. Northwest is number 9. Okay, good. The second and third digits are the year. And we know that this year is 2025, right? Cool. And then the fourth digit is the district number, okay? Digits 5 to 8 are the center or school number. And the last 4 digits are the candidate's number in his or her school. Okay, cool. What a complicated thing there. The examination number may contain digits 0 to 9. Okay, right. So how many are they in total? 10. So please pay attention to numbers and totals. And the digits may be repeated. Okay, cool. Consider only examination numbers for the year 2025 of Northwest and District 4. An example of an examination number is 9 for the province, 25 for the year 2025, 4 for the District 4. Then the center can change around. So here we have got a bit of a leeway. There are no restrictions, but there's hard restrictions on the first 4 digits. Okay, so the question says we need to determine the number of different examination numbers for the year 2025 of Northwest District 4 that can be formed using this system. Right, let's check how many numbers do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 digits here. So 11.1, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So obviously 9 is specific, so there's only one number that we can put there, 9. Then there's only one number for the second digit, which is a 2, so it's only 1. And again, there's only one number we can put for the third digit, which is 5. There's only one number for the fourth digit, which is a 4. Now we start to have a bit of a leeway. Now it says this district number can, the digits can repeat where there's no restriction. So we know that the next 4, it can be all 10 digits repeating nicely when there's a need. And the last 10 can still do the same. All right. So essentially, what do we have here? We've got basically 10 to the exponent 1, 2, 3, 4, 5, 6, 7, 8. So this is 10 to the exponent 8. So this is just going to be 1 and 8 zeros. So this is 100 million different exam numbers. Okay. Nice and easy, guys. So that and the answer, good stuff. 11.2 says, an examination number for the year 2025 of Northwest District 4 is randomly selected. Okay. Now there's a random selection. Calculate the probability that this examination number will have a center number. Can you see? The restriction is now also the center number. Okay, cool. That is even. But it has to be between 8,000 and 500. Okay. very heavy restrictions, and that digits may not repeat. Okay, so remember, when we repeat, it's going to be a number of these put together, including this kind of a restriction that we see. So now we want to look at those ones with the restriction. So first of all, we need to find out the number of ways we can express this. So we know that, okay, essentially, what numbers, if we look at, say, for example, the numbers that can start when we want a number greater than 1,000 but less than 500, it can be 1, 2, 3, 4. So these are the numbers that can begin or that can start the center number. But the numbers that should end the center number, it's even digits. So even digits is 0, 2, 4, 6, and 8, right? So it's all these 5 digits. They can end our center number. So we need to play a very smart trick. Now let's have a look, guys. We can clearly see that of the even numbers, there is a clash of 4 and 4 there. So once there's a clash, we need to think about our center number starting with an even number and still being an even number. And we can also consider our center number starting with an odd number, but still being an even number. Okay, so we need to split, because once there's a clash, we need to split the arguments here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 1, 1, 1, 1 for the first 4 digits because there's strict restrictions there. The last 4, nothing changes from the usual. So we go about it as we saw. Now, we're saying this center number is going to start with an even number. Right? When it starts with an even number, how many of the even numbers can start? Can be 2, can be 4. So there's 2 numbers that can start. But remember, that only represents one number, and we go to the end of the even digits that we need to use. Remember, we can't repeat. So we had 1, 2, 3, 4, 5. So out of 5, we've taken 1 out. So we end up with 4. Okay? So because we're not repeating for the center number. Now out of 10 numbers, we've taken down 2. So we're going to have 8 and 7 because we're not repeating for the center number. Let's talk about an odd start. Again, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perhaps we just give it a bit of space nicely. Right, again, the first 4 digits is going to be the same because it can only be 1, 9, 1, 2, 1, 5, and 1, 4. And the last 4 digits, again, are doing their thing there. We can repeat. The restriction was on the center number. Now let's say we have an odd number beginning. How many odd numbers can we begin with? Is 1 and 3. There's only 2. Right? Now we go to the end. At the end, it's going to be all 5 even digits, because anyone can end this. Then out of 10, we've put down 2, so we're going to have 8 and 7 for that, since we are not repeating for the center number. Now let's evaluate. What is this? This is basically 10 to the exponent 4 times 2 times 8 times 7 times 4. What do we get? So 10 to the exponent 4 times 2 times 8 times 7 times 4, right? So we get 4,480,000. Okay, 4,480,000 exam numbers. Okay, now let's deal with this one again. It's going to be just 2 times 8 times 7 times 5 times 10 to the exponent 4, right? Let's see what that is. 2 times 8 times 7 times 5 times 10 to the exponent 4. This one gives us 5,600,000 exam numbers. Now folks, we add the two to get our total number of possibilities. So we know that the probability of our event is going to be the number of ways that this event can be expressed divided by the number of total outcomes in the sample. So we know that P of our event is going to be this 5,600,000 plus the 4,480,000 divided by the total, which was 10 to the exponent 8. In fact, why do we write it like that? It's 100 million. Right, so therefore our probability of our event occurring is going to be this plus 4480, 1, 2, 3. Then we divide this. We divide this by 100 million. So what do we get there? We get an answer of 63 over 625. Of course, guys, once we get a nice fraction, I leave it here. But as a student, one can push it to a decimal, one can push it to a percentage. Essentially, this is how it's done. Again, guys, I did highlight these in the previous videos. So I'm sure students who paid attention truly did benefit, but those who did not certainly did miss out. So this is a mark, guys, and this is a mark, this is a mark. Yeah, I don't know where the extra mark is, perhaps for splitting these two bonus mark. Anyway, guys, once everything is done, we get our full marks if our answers are correct, pending any mistakes, because remember, these can occur, but we have been very careful and meticulous along the way, and we've been questioning if our answers were sensible at all. And I don't remember finding one that wasn't, but again, in the blink of an eye, things can go wrong. Okay, so guys, this is it for a total of 150 marks, barring any mistakes we may have committed along the way. So I hope you liked the video and that you have learned something, folks. Otherwise, keep practicing and good luck for the final exams. I will see you again next time. Goodbye.